Good morning, everybody. Welcome. It is my pleasure to formally open the 31st annual meeting of the North Pacific Marine Science Organization that we refer to as PICES. Before I make my own opening remarks, I would like to invite the president of the Korean Institute of Ocean Science and Technology, Dr. Woong-Seo Kim, to present the PICES 2022 welcoming address. Dr. Kim.
Good morning, ladies and gentlemen. I'm Woong-Seo Kim, the president of the Korean Institute of Ocean Science and Technology. It's my great honor to greet everyone here at the beautiful ocean city of Busan. I would like to congratulate the opening of PICES 2022 annual meeting under the theme of sustainability of marine ecosystem through global knowledge networks during the UN Decade of Ocean Science. I send my heartfelt appreciation to those who made this meeting possible, including Professor Enrique Kirchhisser, the PICES chairman, Dr. Sonia Batten, and the PICES executive secretaries, and the members of Korea International Cooperation Department of KIOST. The same goes to Deputy Minister Myung-Dal Song at the Ministry of Oceans and Fisheries, Korea, who will give out the congratulatory speeches. I'd better take off the mask. Dr. Soo-Kyung Kang, who will be making the plenary speech, and all other participants who made it to Busan, and those who are attending online due to the worldwide difficult circumstances. Most of all, this year is the first time that the member states are able to actually meet in person and share their opinions ever since the global lockdown due to COVID-19. I send out my warmest consolation and encouragement to our colleagues who have gone through hard times during the course of overcoming the unexpected pandemics. Through this meeting, we would like to catch up on the discussions we haven't had for the last 2 years on what PICES can contribute to the Ocean Decade of Ocean Science, which happens to the most important issue in this field. With the IOC taking the main role, the United Nations have made out the groundwork of the UN Ocean Decade for the sustainable development of the oceans, which is now in its implementation stage since January 2021. After 2 years planning from 2018 to 2020. While the beginning has not been so smooth due to COVID-19, scientists, policymakers, international organizations, NGOs around the world are working together to propose scientific capacity and knowledge building to find a solution to SDG number 14. The ultimate goal to the Ocean Decade, as well as other SDGs, will provide the foundation to move from the science we need toward the ocean we want. Record-breaking high temperatures, heavy rains, and worst drought in a century are no longer something new to us. During this era of natural disasters, it is our mission to use all potential we have to accelerate the innovative ocean science-related solutions to make the sustainable development possible. During this meeting, I hope to see PICES to reaffirm its scientific capacity acquired from the North Pacific region for the last 30 years. I also suggest that this scientific knowledge become a topic for discussion among many stakeholders and professionals to find a way to overcome climate crisis and enter the state of sustainable development. I would like to take these opportunities to congratulate the 30th birthday of PICES. I expect to see PICES acting as the future of ocean science on its 40th and 50th birthday as well. I congratulate the opening the PICES 2022 annual meetings once again, and send my gratitude to everyone who is attending on and offline. I hope the offline participants enjoy your stay in Busan and have a lot of good memories. Thank you.
Thank you very much, Dr. Kim. Dear Deputy Minister of Marine Policy in the Office of Ministry of Ocean and Fisheries, Mr. Myung-Dal Song, President of KIOS, Dr. Wong Seo Kim, national delegates, science board members, working group members, and the PICES community at large. After 2 years of resilience, online meetings, way too many emails, communications, being apart as a community, I'm especially honored to be here in Busan for the 31st annual PICES meeting. I want to begin by offering my heartfelt appreciation for the work of our colleagues at KIOS and the Korean delegation have done to organize this meeting, and of course, the tireless work of the PICES Secretariat. Our last in-person meeting was in 2019. Many of us have traveled great distances to get here. Mask requirements, thank you. Vaccines, contact tracing, they're all a reminder that we're still learning how to live with and deal with the effects of the global COVID pandemic. These days, we can also not ignore the political challenges that are directly impacting our community of scientists. What have not changed are the environmental challenges that we face and the urgent need for both knowledge and actionable solutions. From super typhoons in the Western Pacific, marine heat waves in the Eastern Pacific, fish populations that are shifting in response to a changing environment, sea level rise, increased occurrences of harmful algal blooms, coastal erosion, consequences of all of this to human populations. Indeed, more than ever, we need all of our expertise and knowledge in the service of humanity. PICES was founded with the idea that by working together and collaborating and sharing knowledge, we will make faster and more informed progress. So despite of all the immediate challenges, our opportunities for collaboration are increasing. To some degree, this is crystallized by the ongoing UN Decade of Ocean Sciences, in which PICES science and scientists are well represented, in particular by the joint PICES-ICES SmartNet and other UN Decade activities. SmartNet ambitions guided the theme for this annual meeting, sustainability of marine ecosystems through global knowledge networks. You will hear much more about that and SmartNet throughout the week. We're also living through a period of increased technological capabilities in ocean sampling, more reliable numerical models from the weather to the climate scales, all of which permit us to probe new questions and offer science-based service to society. It is an exciting and important time to be engaged in science. Judging by the program of this meeting and the ongoing activities of our organization, PICES is rising to the challenge. I will note our science program Future, which is now entering in its third phase, the work of our advisory panels, our committees, which convene topical working groups, study groups that drive the PICES science forward. You will hear much more about this from our Science Board Chair, Dr. Traynor, a bit later this morning. Lastly, I would like to highlight our increased focus on the early career ocean professionals, also known as ECOPs, in our organization. For those of us that have been around for a while, I encourage you and urge you to engage with this cohort of enthusiastic and smart scientists. I personally look forward to catching up with many of you that I've not had a chance to see in a few years, and look forward to meeting new people as well. I would like to thank the sponsors for our meeting, the Ministry of Ocean and Fisheries in Korea, KIOST, and the Busan Tourist Organization. Have a great and exciting meeting. Thank you. I would like now to introduce you to the Deputy Minister of Marine Policy in the Office of Ministry of Fisheries, Mr. Myung-Dal Song, to make some opening remarks as well.
Dr. Enrique Colchicher, the PICES Chairman, Dr. Sonia Beton, Executive Secretary, Dr. Vera Traynor, Science Board Chair, distinguished guest delegates, ladies and gentlemen, I would like to extend my sincere welcome to the PICES member scientists and participants to the Republic of Korea. Busan holds special significance as the city where the 1997 annual meeting of PICES took place, when Korea hosted the PICES meeting for the first time. Fast forward 2 decades and a half, world-renowned scientists and scholars are again gathered here in Busan for another annual meeting of PICES, and I'm honored and pleased to take part in this meaningful event. Moreover, as this is the first face-to-face meeting since the outbreak of COVID-19 pandemic in 2020, I have high expectations that it will provide opportunities for us to engage with each other even more closely to move forward the discussions on the progress of ocean science for stronger international cooperation and brighter future in the fields of oceans and fisheries. I would consider that the ocean is a huge bowl that contains not just living organisms, but just carbon dioxide released in the atmosphere and marine litter that pollute marine environments and impact climate. In a sense, the ocean has the arms open to everything without judging. Perhaps this is why the origin of the Korean word for ocean, 바다, comes from 받아들이다, which means to embrace. However, the ocean that used to embrace everything now seems to have reached the limits. Sea levels keep rising, while sea surface temperatures are frequently reaching record-breaking highs. These changes are affecting climate patterns that are starkly demonstrated by historic heat waves, droughts, and torrential rains that we are witnessing on a global scale. We are running against time. We need to act now with a sharper sense of urgency than ever to make our best effort to attain goal number 14 of the UN SDG that mandates us to conserve and sustainably use the oceans, seas, and marine resources for sustainable development. As part of these efforts, UNESCO and IOC have launched the UN Ocean Decade last year. Ocean scientists and policymakers from all around the world are working together on this project to save our ocean. As PICES boasts a huge pool of data and information, expertise, and experience on international cooperation that have been built over the last 3 decades, I'm convinced that the participation of PICES in the UN Ocean Decade will make significant contribution to sustainable development of ocean. I hope that the academic presentations and robust discussions during the meeting will add on to the joint efforts of the international community to reach the goal of sustainable development of the ocean set by the UN Ocean Decade and provide insights into climate change responses and carbon neutrality. Before I close, I would like to take this opportunity to express my heartfelt appreciation to the PICES Secretariat and KIOST who organized the annual meeting, and also to those who worked behind the scenes to bring us all together. I would like to once again thank our PICES scientists and participants for traveling from afar to visit Korea, and I hope that the 2022 annual meeting of PICES will produce fruitful outcomes through the full and lively exchange of ideas and thoughts. Thank you.
So some of the more warming and beautiful traditions that we have at PICES is to recognize the work of many of our colleagues that have contributed significantly to the organization over the years. And myself, I will present the Chair Award, and then Vera will present the other awards. The first award, the Chair Award, was established in 2016 by the Governing Council of the organization, and the idea is to reward and award individuals that have done sustained contributions to the development of PICES and its organization. So past awardees of this are Rick Marasco from the US and Alex Bichkov, who was our from PICES Secretariat, Tokyo Wada and John Stein in 2018, Pat Livingston in 2019, and our past Governing Council chairperson, Laura Richards, in last year. So for the 2022 PICES Chair Award, we are very happy to award it to Dr. Chul Park, who is with us here in the audience. A little bit about Dr. Park, just in case you're not familiar with everything he has done. He is currently serving as the past chair of Governing Council. And as such, it may sound like an easy thing to do, but his main role is to advise the current chair, that being me, and I hear that sometimes that can be a difficult thing to do. But he makes sure that I am up to doing everything that I need to be doing as the current chair. Before being the past chair, the acting past chair, he was the chair of the Governing Council. He served on the Finance and Administration Committee at PICES, governing representative for Korea since 2009, vice chair in 2012 for 4 years before becoming the chair. Specifically, Dr. Park was a strong advocate for PICES within the Korean science community, leading to increased participation by Korean scientists in PICES. So we're honored to present this award to you.
Frankly speaking, I don't know whether I deserve receiving this one award. If I knew it earlier, I should have refused to receiving it. Thank you. As I mentioned, I'm not I don't know whether I deserve to receiving this one. One reason is I was one of the member who established this award. So obviously I'm not supposed to have this award, but anyway, thank you very much.
So we'll continue with awards, which is really the fun part of the meeting, recognizing some of our amazing colleagues. We have our deep gratitude for the vision that Dr. Wooster had to form PICES, to allow this collaboration in the North Pacific. The Wooster Award was established in the year 2000, and it recognizes annually an individual who has made a significant scientific contribution to North Pacific marine science. The person has exhibited sustained excellence in research, teaching, administration, or a combination of the three. And special consideration is given to an individual who has connected the various aspects of marine science. There is a video that will give a presentation on the individual who is the awardee, and I'm going to let the video speak for itself.
PICES Wooster Award is the highest award granted to a PICES scientist. It is named in honor of Professor Warren S. Wooster, founder and first chair of PICES and a world-renowned statesman and climate variability and fisheries production researcher. The award is given annually to an individual who has made significant scientific contributions to North Pacific marine science, such as understanding and predicting the role of human and climate interactions on marine ecosystem production. There have been many illustrious past recipients of the Worcester Award. This year, the person recommended by PICES Science Board and approved by PICES Governing Council as the recipient of the 2022 Worcester Award is Dr. Harold Batchelder, affectionately known as Hal to his PICES colleagues. Hal was born to his parents, Mark, a structural engineer, and Janet, a homemaker, in Glen Cove, New York. Shortly after Hal's birth, they moved to the Boston area, where Hal's brother Mark and sister Anne were born. He spent most of his early years in New England, completing elementary, junior, and senior years in the Boston area. During the summers, Hal's family and grandparents spent lots of time in Hampton Beach, New Hampshire, and hiking on Mount Washington in New Hampshire. It's during these trips that Hal's love of the ocean and forests was sparked. Hal moved to Maine for college in 1973, studying biological sciences. Then, in 1977, Hal moved to the Pacific Coast, to Oregon State University, Newport, and Corvallis, completing his master's degree in oceanography on the population dynamics and structure of intertidal sea anemones under Charlie Miller. Hal successfully juggled his university career and gained additional field experience when Charlie hired Hal and 2 others to do oceanographic sampling and taxonomic analysis of zooplankton samples collected aboard Canadian ocean weather ships Quadra and Vancouver at Station Papa in the North Pacific. Hal received his PhD from Oregon State University in 1986 under Charlie Miller, using zooplankton samples from the subarctic Pacific. His parents were very proud, with his mother regularly joking about Hal being her son the doctor, but not the kind that would do her any good. Following his PhD, Hal held postdoctoral and marine scientist positions at the University of Rhode Island, with research programs and cruises in the Sargasso Sea and subarctic North Atlantic, before returning to the Pacific Coast to become the first scientific director of the National U.S. Globex Steering Committee office in California. In California, Hal loved spending his spare time hiking in the Sierra Mountains and sailing on San Francisco Bay. It was during Hal's time at Globex that PICES was founded. Following his Globex adventures, Hal joined the faculty of Oregon State University. His distinguished career as professor allowed him to champion and encourage many students and early career ocean professionals, including supervision of 4 PhD students and 3 master's students, as well as serving on numerous graduate student committees. During this time, he also served as deputy director for the NOAA OSU Cooperative Institute for Oceanographic Satellite Studies from 2008 to 2014. In addition to encouraging his OSU students, Hal also worked tirelessly to facilitate early career scientist involvement in international meetings and symposia. He had active roles in planning the PICES Early Career Scientist Conference in Busan in 2017, worked from 2012 to 2021 as a member of the SCORE Capacity Building Committee, and in PICES, he set up the marine science talks at middle schools in Qingdao in 2015. He was a keen supporter of early career scientists and the move to form an expert group dedicated to growing the role of ECOPS within PICES. Hal's long involvement in PICES began with his attendance at PICES 1993 in Seattle, shortly after PICES' inception. He later became involved with many expert groups, including as co-chair of the Climate Change and Carrying Capacity Program, known as 4Cs. He was a member of Science Board for 8 years and U.S. delegate to Governing Council in 2012-2013. Hal was instrumental in planning for and launching PICES' Successful Future program and continued to follow and contribute to its progress since its inception. Hal joined PICES as Deputy Executive Secretary in 2014, a role that he filled until his retirement in 2021. During Hal's time at PICES, he filled multiple functions, coordinated expert groups, planned meetings and symposia, and shepherded many PICES publications to completion, including the first North Pacific Ecosystem Status Report, one of PICES' premier contributions to marine ecosystem science. Hal's international work also goes beyond both GLOBEC and PICES, as he has contributed internationally through many workshops, symposia, and has made significant contributions in the process. Throughout his career, Hal has been a passionate and accomplished advocate for international cross-disciplinary marine sciences. And with PICES colleagues, was also a fashion trendsetter. Hal has helped to encourage the next generation of marine scientists, and he also helped to set the stage for the United Nations Decade of Ocean Science for Sustainable Development. Hal's career as an internationally recognized biological oceanographer and ocean ecologist has contributed to advancing our collective understanding of zooplankton ecology, biological physical coupling, and marine ecosystem dynamics. Hal has published over 50 frequently cited journal articles in top-ranked international journals and, on behalf of both GLOBEC and PICES, has significantly contributed to and collaborated with colleagues to produce several overview and synthesis articles that collectively contribute to our understanding of the world's oceans and how best to facilitate our marine science initiatives to forward our understanding. And all the while, Hal took time to enjoy life with colleagues, friends, and family, including kayaking and biking, spending time with Secretariat colleagues, and braving the waters with other fellow PICES swim team members. Hal is happy to have slowed down in his retirement, and he loves spending time with his grandchildren, his fur babies, and his adoring wife, Stephanie. Hal, PICES is proud to award you its highest award, the Wooster Award for 2022. We wish you a very happy retirement. Congratulations. In early September 2022, a group of PICES members and executives traveled to Oregon to present Hal with his Wooster Award. It was the perfect opportunity for close colleagues and conspirators to spend some time with Hal during his retirement and to celebrate his award. Hal was very proud to receive the PICES Wooster Award and thanked all PICES members, saying, "I really enjoyed all my time at PICES, all the interesting people that attended the PICES meetings, and I want to thank you for this award." Congratulations, Hal, on the 2022 Wooster Award. We wish you all the best from everyone at PICES.
So Hal couldn't be here, but what a wonderful person who has influenced so many of us. And thank you to the Secretariat, especially Lori Waters, for putting together that amazing video. So continuing on, our next award is the Zhu Peterson Award, which is one of my favorites. And I was lucky enough to have met both Professor Zhu and Dr. Peterson, who were strong advocates for early career ocean professionals. They provided incredible mentorship for early career ocean professionals in their laboratories and also here in PICES. So the Zhu Peterson Award is named in honor of them and is given annually to an individual who's performed innovative research at the frontier of science relevant to the PICES mission as set out in the PICES Convention. And the winner of this year's Drew Peterson Award is Dr. Matt Savoca.
Hello. Hello. Well, this is a great honor and quite a surprise. I have to thank Stephen Bograd, who I'm sure I need to, give a pat on the back for, because without him, I wouldn't be here and be involved in this organization. And it's really been like a fun scientific family and one I intend to be a part of for many years to come. So thank you, everyone. Thank you, Stephen. And yeah, very, very happy to be here and accept this award. Really appreciate it.
So a little bit about Matt. So he's a researcher at Stanford University. He got his bachelor's at Cornell University and his PhD at UC Davis. He was the winner of the 2018 SciLife Lab Prize for Young Scientists at the Nobel ceremony in Stockholm, which is amazing. And he's an interdisciplinary marine ecologist who's done work on climate change, has worked with cetaceans, and also has looked at marine debris and pollution. And please take a picture of this QR code and look at some of his amazing blogs that he's done on marine mammals and plastics and a variety of things. He was a founding member here in PICES of Working Group 42 on indicators of marine plastic pollution, is a member of the advisory panel on early career ocean professionals, and is an amazing science communicator. So again, congratulations, Matt. Okay, so, sorry about that. So our next award is the PICES Ocean Monitoring Award, and many of us benefit from long-term monitoring data, but it's usually the work that can go unrecognized. So in realization of this, PICES has established the POMA Award to enlighten the public on the importance of these activities and to promote the collection and exchange of information and data related to marine science research in this area. So the winner of the POMA Award is the Japanese Monitoring Research Activity on Mesozooplankton.
first, I would like to thank all related scientists and crew of the research vessels and related students and staffs who organize the sample collection and taxpayer of the Japan. And nothing more, I would like to thank about to the Dr. Kazuko Date, who started to collect the zooplankton sample collection. I'm very happy to relate it to the sample collection, wonderful sample collection, and I would also like to thank the PICES people for understand the sample collection and for choosing the POMA award. Now the sample collection is growing and using for the various study programs. I would like to collaborate with sample collection, collaborate with using the sample collection with PICE people. So if you have interested in the sample collection, please contact me. Thank you very much.
And just a little bit more on the Japanese monitoring research activities on mesozooplankton. It's a very long time series that began in 1949 and has lasted longer than a half century. Over 17,000 zooplankton tows have been done, and the program has been very important in looking at zooplankton biomass changes during climate change and has helped to inform research in this area, and has also contributed to our knowledge in looking at fisheries productivity in the region. So congratulations again on the POMA award. Okay. So now it's my great pleasure as Science Board Chair to give you a year in review to highlight some of the activities that have been happening during PICES. The conference here, and it's so exciting to be together again in person to see one another in 3D here in lovely Haeundae Beach. The title of this conference is Sustainability of Marine Ecosystems. Some of us have been here for workshops before the meeting, and now we have the body of the meeting that is beginning. So it's so wonderful to see everyone in person. So as you know, many of you know, the scientific program within PICES is Future, forecasting and understanding trends, uncertainty, and responses of North Pacific marine ecosystems. And Future has been in place for many years, over a decade. And I would say the primary achievement of Future has been to foster collaboration within PICES. One of the highlights is the establishment of the Committee on Human Dimensions. So we're looking more at the social, ecological, environmental systems that PICES research covers. And as we move forward into Future Phase 3, I encourage all expert groups to think about how they can connect their work with one another to bring in aspects of social science and other parts of research. So the Phase 3 priorities are to retain this flagship program within PICES. So to really focus on PICES scientists and how our family can work well together. Some of the other highlights are to bring in early career ocean professionals to bring new voices to Future. To also foster cross-pollination, so cross-collaboration within the various groups of Pisces, including Future, the Advisory Panel on the UN Decade, the Advisory Panel on Early Career Ocean Professionals, or ECOP, and also the Advisory Panel on Science Communication, among others. We will have a renewed focus on science-based solutions and operational products. And in a couple years, we really need to begin thinking about what the next science program within Pisces will be. Future does have an Early Career Professional SEAS Award. So this goes to a person for travel support up to $3,000 Canadian, and in particular, an early career ocean professional whose work is focusing on this integrated SEAS approach, the social, ecological, environmental systems approach. So early career scientists, please apply, because there is some funding for your travel, especially if you're doing work to integrate different science disciplines. So at the beginning of the UN Decade of Ocean Sciences for Sustainable Development, and actually prior to beginning of 2021, Pisces started its conversations with its sister organization in the Atlantic, PICES, to look at developing a program together to see how we could better collaborate. And the name of the program that has been accepted by the UN Decade is the Sustainability of Marine Ecosystems Through Global Knowledge Networks, SmartNet. And you'll hear a bit more about SmartNet later today. This is really an effort for Pisces to expand its research into communities, into areas where maybe it hasn't typically worked in the past, like small island developing states and others. And I think this is an opportunity for us to really look at the relevance of our science and to make sure that it is helping communities with what they need, especially during climate change. So some of the goals of SmartNet, and SmartNet is steered by a joint steering committee, fondly called IPOD, the ICES-Pisces Ocean Decade Committee, and there are chairs from both ICES and Pisces, as you can see here. And again, part of the strategic plan is to really focus on engagement. How can we make our science relevant? To look at partners who can help with this, and to encourage and support the expert groups within Pisces to work together within, but then also to look for partners outside. Pisces has a number of conferences that have been endorsed, including in July 2022, there was an ICES-Pisces Early Career Scientist Conference in St. John's, Newfoundland. So one of the first post-COVID wonderful meetings of our early career ocean professionals. As I mentioned, SmartNet is a program that has been endorsed. We look forward to the Small Pelagic Fish Conference, which will be held in Lisbon, Portugal in November of this year. And then the MC's conference, which is, has been delayed several times and will be held in 2024. So stay tuned. Please look at Pisces' website for more details about these endorsed activities. I want to take a few moments to highlight a couple of the advisory panels within Pisces. All of the expert groups are very important, but these are some advisory panels that have cross-cutting themes that all of you should be aware of. So the advisory panel on ECOP, or Early Career Ocean Professionals, we really see, or they really see themselves as the cross-pollinators. People who are going to go from group to group and really work on integration. So it's a very exciting time for Pisces, really looking at succession planning and who are the next generation leaders who are going to now work with us. So there is a mentorship platform that's being established for those of you who are interested in becoming mentors or would like to be mentored, please stay tuned. Contact any of us who are more seasoned people within PICES to get more information about this. The ECOP are also connecting with other early career networks throughout the world, really. So that's an exciting way for PICES to connect with other organizations. And they've been quite active in a number of international ocean conferences. The ECOP have taken the time to put together flyers for one another to look at engagement opportunities of low, medium, and high commitment. And I think you can see some of these brochures at the registration desks. So they have been translated into a number of languages to make sure that ECOP are comfortable reading in their languages and understand the content of these particular activities. We will be having a symposium just following the PICES conference. There's a banner by the registration desk as well. This will be joint with SCORE and KIOST. So another opportunity to engage with ECOP and see what they're all about. So please take a look. Those folks who are ECOP, many of them will have a ECOP sign, a little ECOP sticker on their badges. And folks who are engaged with ECOP, and I'm lucky to have a smiley face on my badge because I've been helping with the advisory panel. Could the ECOP in the room raise their hands? So these are the folks that I would like you to talk to about PICES, and please welcome them because they are the next generation. Another advisory panel within PICES is the Science Communication Advisory Panel. We were busy over the weekend doing some work with Brian Palermo, who has actually worked in Hollywood, and spoke with us about how to communicate our science. And during this workshop, we were able to create 3 videos. Stay tuned during S1, and I think you're going to be treated by seeing one of the videos that was created, and I won't be saying too much more about that. The Secretariat is also working on a new improved PICES website, not to take away any of the content that is there, but to have a more aesthetically pleasing landing page so that when you point your directors or you point your family members to the PICES website, they will be able to find some basic information that will really tell them what PICES is all about. So we look forward to that. There are several new PICES expert groups that are listed here. The Pacific Salmon Commission has a study group. The Asia Pacific Network and PICES also has a study group. And then there's one on green. So that is an acronym that is basically looking at generating recommendations for environmentally friendly solutions. So as we move out of COVID, we really need to think about, in particular, those colleagues who couldn't be here. Not everyone is getting permission to come to this conference. So what is the meeting of the future? What will it look like? And that's one of the goals of Study Group Green, is to come up with recommendations for how we want to hold meetings in the future. Will they be hybrid? Will there be a virtual aspect or not? If you're interested in participating in Study Group Green, it's only 1 year, please contact me. So the study groups are typically a 1-year duration, whereas the working groups are longer. They're 3 to 5 years. There's an exciting new working group on climate extremes, another one on sub-mesoscale processes, and then, as I mentioned in my previous slides, there are the 3 new advisory panels. There are a number of, or a couple of special projects that are sponsored by PICES member countries. This is if there is a topic of interest that, that countries want to see more research done in. So for example, the Ciguatera project, a harmful algal species, work that's being done in Indonesia is sponsored by the government of Japan. And then there's a separate sea turtle project that is of interest to the government of Korea, and they've asked for PICES scientists to be involved in this. So these are two special projects. There are a number of publications, and I'm not going to read all of these, but please go to the PICES website, pices.int/publications, to see some of these new works that scientists have been very busy writing over the last couple of years. And they range from work describing the oceanography of the East China Sea and Yellow Sea to looking at economic impacts of harmful algal blooms. There are a number of activities in which PICES has been involved, looking at capacity development, and I've already mentioned this early career conference that was in St. John's. Here you can see a number of the folks who attended. There is another conference, the Pacific Ecology and Evolution Conference, that was held earlier this spring. And a couple of other capacity development summer schools, one on ocean turbulence and another on ocean big data that were held this summer. We have a PICES intern. Please say hello at the registration desk. Cecil has been with us for several years. And we're looking forward to proposing possibly a new intern who will be involved in UN Decade work. So Governing Council, this is coming to you. So we are hoping that this will be supported because the UN Decade is a big job, and making sure we get it right is very important. And then a little sad note, we lost one of the science greats this year. Tim Parsons has been involved in PICES for a number of years. He was really a wonderful scientist who's written books and had a number of publications. He was involved in many national and international projects and received many awards and honors. And he was active in PICES during its early years and was one of the folks who established the Bio Committee and was a keynote speaker in 1996 in Nanaimo. He's had a wonderful lifetime of scientific achievement with over 150 primary publications, 3 honorary doctorate degrees, and many other significant awards. Tim was prolific, and he will be greatly, greatly missed. So to take a moment to think about all of our colleagues who we've lost and all of our friends who we've lost, but in particular, Tim, we're sad that we lost him this year. So moving on, PICES has a number of collaborations and partnerships. We're hoping that this list expands now during the UN Decade, but we are grateful for all of the wonderful collaborations that are made possible by having PICES as a scientific organization that reaches out to many others through our science. And we look forward to seeing you at several upcoming PICES scientific events, including the Small Pelagic Fish Conference, which is in lovely Lisbon, Portugal in November, the EQUO Conference, which is coming up in Bergen, Norway in 2023, and we are now at the PICES Conference 2022, but look forward to going to Seattle in 2023, which is my home. So I welcome you there next year. We also have in Hobart, Tasmania, the ZPS 7 conference, And then the MC's conference has been delayed many times, and it will now be held in 2024. So please take a look at the conference section in the PICES website if you would like to have more information about these. I want to extend particular thanks to the local organizing committee. It's a huge job to put on a conference like this, and we are all benefiting from the incredible organizational skills of the local folks. And in particular, I want to extend my deep gratitude to the PICES Secretariat staff who've made my job a lot easier. So please poke your head into the Secretariat office or to the registration desk and extend your thanks to all of them, because without them, this could not happen. So please join us after our plenary address. We will have the S1 section, a little teaser. We're going to have a great video, but there are a number of really good talks that are going to focus on our work through PICES as part of the UN Decade of Ocean Sciences for Sustainable Development. So this will give you a sense of how you might be able to get more involved in the UN Decade. And I think with that, I'm going to hand it over to you, Sanai. Thank you all for listening, and thank you for being here.
Okay. Good morning, PICES. Good morning. Look at you. So many people here. I'm so happy to see, excited to see you. So many people coming. I really would like to say thank you very much for coming. Thank you very much for coming. And also would like to say thank you for KIOST and also Korean government for preparing this event such perfectly and nicely. So I'm here to give you useful information that make your life a little bit easier during annual meeting. So this is essential. Your name tag is your passport. Okay, so don't forget to have it. So without this, you could be rejected to enter. Okay, and as Vera explained, the ECOP member has a blue tag here. So if you find them, thank you very much. I really like this kindness constellation. Thank you very much. Now I can see you better. Okay, so if you find the blue tag with the ECOP, please talk to them and intimidate them and or be intimidated by them. And also, I have also this, the smiley mark here. So this means I'm not gonna bite you. Okay, so please talk to me and come to talk to me. And next, the PICES Wi-Fi is here, and password is here. And you can find this information in the registration desk too. And face mask. Please wear your face mask inside the building, but except coffee break and the reception. And speaker can take off your face mask when you are speaking. And there are several events, social events and others during this weekend, during this week. So today, from 6:30, we will have a welcome reception at this room. So again, don't forget your name tag. Then inside of your pocket is drink ticket. This is very important to have. And two of them are for today's welcome reception, and another two are for the poster presentation, reception or poster presentation Thursday. And tomorrow, Tuesday, is the day of the sports event. So in the evening, we will enjoy this year bowling. And you can find the detail at the registration desk. But max number of the participants is 50. So please go to and sign up before the old ticket is gone. And yep, enjoy. And Thursday is a poster presentation. And the poster presentation takes place also this room. But the poster will be presented from tomorrow morning. So the presenter, please don't forget, put your poster on tomorrow morning. It's just far side of this room. And Friday, during the closing ceremony, the early career scientist presentation awards are announced. And I would like to ask you a couple of things. So for speakers, please give your presentation file to convener before the session and workshop, way in advance. And also, as you know, there are lots of drama for holding this conference until now. Then, unfortunately, the drama is still ongoing. So please be aware the change of your schedule, and please check the latest schedule on website, also the post and near the registration desk. And even if there is a last-minute change, please keep calm and carry on. And please be flexible and creative and be happy. And also, I would like to ask the conveners, please take photos, nice photos of your session, and share those photos with us, either by sending an email to Lori or tweeted those photos. And at last, and most importantly, English is not a primary language for many of the participants. So it is a tradition, PICES tradition, at the closing ceremony, the PICES deputy asks you, speak slowly. But I would like to improvise that message a little bit, because the most important things for the better communication is not really speed, but that is a consideration and willingness to understand each other. So PICES countries consist of only six member countries, but cultural diversity is really high among us. So let's celebrate our diversity and communicate thoughtfully. So that is our message, and that concludes the opening ceremony. And so the coffee, we will have a little bit longer coffee break, and the coffee is ready near the reception desk. And after the coffee break is a keynote speech by Dr. Shukyun Kang, and followed by the Science World Symposium. So please be back by the 11 o'clock. Don't miss the good stuff. Thank you very much.
Welcome back, everyone. This is S1, Sustainability of Marine Ecosystems Through Global Knowledge Networks during the UN Decade of Ocean Sciences. So this is the session that is sponsored by the Science Board. I was hoping that the Science Board members would raise their hands or stand, just so everyone knows who you are. Okay, they're a little shy, so they're just raising their hands. So some of the Science Board members will be introducing the upcoming speakers. But first, it gives me great pleasure to introduce the plenary speaker. Can we get this to advance? There we go. Okay, Dr. Suk-Young Kang. She is the director of the Fisheries Resource Research Center of the National Institute of Fisheries Science here in Korea. She received her master's in marine biology from Busan National University and her PhD in fisheries oceanography from Pukyong National University. Her interests include understanding the role of climate change in marine ecosystems and fisheries production, and also looking at the assessment of Korean fisheries to climate change and providing advice, which I think is going to become more and more important during the UN decade. She has been involved in a number of international organizations, including PICES. Within PICES, and how I know her best, is as the co-chair of the Future Program, which you learned about a little bit this morning. She has also been a member of the section SICME, Climate Change Effects on Marine Ecosystems. She's a member of FIS, the Fisheries Science Committee, and Working Group 43. And I will pass the baton to her as the brand new Science Board Chair at the end of this meeting. So it gives me great pleasure to introduce you, Suk-Young, for the plenary.
Okay, thank you, Vera. Good morning, and welcome to Busan, the city of the ocean and my hometown. It's a pleasure to meet you in person here in Busan after overcoming the COVID-19 pandemic. Today, I'm going to talk about Korea's engagement with the UN Decade of Ocean Science. Okay, I will introduce the goals of UN Decade of Ocean Science and then talk about Korea's current engagement and potential engagement. And lastly, I will address gaps and future direction of Korea's engagement with the UN Decade of Ocean Science. Hopefully, this may serve as an example framework for the other PICES member nations and PICES itself to address the decade outcomes. As you may have understood from the scopes of recent PICES annual meeting, the idea of the UN Decade of Ocean Science for sustainability has been with us for several years. In December 2017, UN General Assembly proclaimed the UN Decade of Ocean Science for Sustainable Development 2021 to 2030. I guess most of you are familiar with this tagline, the science we need for the ocean we want. The decade is coordinated by UN Intergovernmental Oceanographic Commission. Now we can see here the framework and steps the IOC envisioned in ocean decade to move from the ocean we have to the ocean we want. Decade has three objectives: to identify required knowledge for sustainable development, and then generate comprehensive knowledge and understanding of the ocean, and then increase the use of the ocean knowledge. The question is, how do we achieve these goals? Among the decade, there are different kinds of the engagement called decade actions. So there are different levels of engagement, called programs, project, activity, and contributions. These decade actions provide the science we need to deal with ocean decade challenges and get to the ocean we want, to be called decade outcomes. There are 7 decade outcomes: a clean ocean, and healthy and resilient ocean, and productive ocean, predicted ocean, safe ocean, and unaccessible ocean, and inspiring and engaging ocean. Here are the 10 ocean decade challenges. These are the most immediate and pressing needs of the decade, and each challenge contributes to one or more decade outcomes. I'm not going to read all of these. So, many countries and international organizations are putting significant energy into the UN Ocean Decade. Korea is also aiming to align its effort with the 7 decade outcomes. And from now on, I'm going to share Korea's support for and engagement with the UN Ocean Decade. During the preparatory phase, we provided financial and human resources for the Ocean Decade from the first initiative. The Ministry of Oceans and Fisheries signed MOU with the IOC and allocated budget for implementary planning. And Dr. Yunori from KIOST served as a member of the executive planning groups. After launch, MOP provides funding every year as a member of UN Ocean Decade Alliance. And domestically, MOP plans to support the UN Ocean Decade in the form of the national R&D programs. Like other nations, we have established the National UN Decade of Ocean Science Committee, more precisely IOC UNDOS Committee under the Korea Oceanographic Commission. And KOC promotes the UN Decade by encouraging and guiding project submission to the Decade course. There are 3 endorsed projects and 1 activity. I'm going to introduce later in detail. And as a part of the public relation activities, the KOC published the Korean version implementation for the UN Decade of Ocean Science and held specific session to promote the Ocean Decade during their annual meeting. These are their projects and activities. From now on, I'm going to introduce each of them briefly. The first project is Mesopelagic Ecosystem Biofilm Dynamics and Connectivity in the Pacific. This is a part of the jet zone program. The goal of this project is to understand the mesopelagic ecosystem in the Pacific in terms of the species diversity, distribution and biomass, food web connectivity, biological pump and carbon flux, water column mixing, and nutrient recycling. We believe the result of this project could contribute healthy ocean and productive ocean and inspiring and engaging ocean. This is the target area. They got some preliminary result from the acoustic survey along with the eDNA and MOCNIS investigation. Second project is the ocean effects on climate variability of the Northwest Pacific. The goal of this project is to enhance understanding how the climate variability in the Northwest Pacific together with remote changes in the Indian Ocean modulate regional changes in the Northwest Pacific ecosystem. As you can see here, this project has two target areas, Northwest Pacific and Indian Ocean. As we only have research ongoing in the Indian Ocean, I will introduce some of their activities. The activities in the Indian Ocean include the cooperative observation and data sharing, intercomparison of a model, and then collaborated development of a prediction model. This result could contribute to the predicted ocean and productive ocean and unaccessible ocean. The most recent endorsed one is the sub-seasonal to seasonal North Pacific predictions. Actually, the official announcement was not made yet, maybe later this month or early next month. This is attached to the 4C, the Ocean Prediction Capacity of the Future program. One endorsed activity is Ocean Science Big Data Contest. It is in progress for activation of database marine literacy in the middle and high school. The winner will be decided on November 22nd. So far, we have looked at Korea's engagement for the ocean decade. From now on, I will introduce several actions taken in Korea could contribute to the UN decade. These are the marine leader activity, multi-hazard warning system, and fish love band campaign, and early career ocean professional support. Korea is making a lot of effort for a clean ocean. The Korean government established an act for management of marine garbage and contaminated marine sediment. It includes a policy to reduce ocean plastic waste by 6% by 2030 and achieve zero by 2050. We also established the Marine Litter Management Center on the COAM, with Korea Marine Environmental Management Corporation. Center built Marine Litter Integrated Information System is a place to find the marine litter related information accumulated over the last 10 years, mostly collected in the coastal areas. National Institute of Fisheries Science analyzed the seabed litter collected by the troll surveys in entire Korean EEZ. You can see where the marine litter hotspot is. Fisheries are also voluntarily working for a clean ocean. Yeah, fishermen, actually. Fisheries cooperative, local residents, and NGOs jointly or separately conduct the Blue Sea movement across the country. Suyap Bank, even they develop a ESG financial product named Marine Plastic Zero to reduce marine litter in association with MOF. As an outreach activity, we are interacting with the Philippines to enhance marine litter management in the Philippines. There were changes in the R&D for marine plastic pollutions. Before the ocean decade, the research and development program for marine plastic pollution focused on the monitoring of the macroplastic litter on shoreline and assessment of marine input load of the land-based plastic litters. Current and future R&D program focused on the monitoring of micro and macroplastic litter on shoreline, floating, and seabed, and also assessment of the impact of marine macroplastic and microplastic debris on marine ecosystems and organisms. Finally, we would like to develop the marine plastic collection and treatment on board and treatment on shore and smart spotting system. These activities related to the marine litter could contribute to clean ocean, safe ocean, and productive ocean, especially for the PICES Working Group 42, which is on marine plastic pollution. The type of natural disasters are diversing. This is the second potential area Korea can contribute. Multi-hazard warning system. The type of natural disasters such as marine heat wave and cold event, HAP, and deoxygenation and inflow of the macroalgae, low salinity, there are many. So the economic loss of the aquaculture caused by natural disaster has reached $236 million in Korea in last 10 years. After severe economic damage by the marine heat wave in the summer of 2016, we had strengthened the real-time monitoring surveys along the coast of Korea, and also developed real-time information system for aquaculture. We measure temperature, salinity, dissolved oxygen every 30 times and measure the data are sent to the NIFS server in real time. The collected information is provided to the fishermen in various ways, like a smartphone application, text messages, and use Flash. Did I do something wrong? Okay. We also operate the high-resolution prediction model around the southern part of the Korean Peninsula, where the most fish farms are located. The prediction model has a spatial resolution of about 300 meters and 3 days prediction of the physical properties. For more accurate prediction, the system improvement is on the way now. We also provide the countermeasure information to the fishermen to reduce the impact of the abrupt water temperature changes. These activities could contribute the predictive ocean and productive ocean, and also PICES Working Group 49 on climate extreme and human dimension committee. Have you recognized what this is on the screen? The massive inflow of the macroalgae is causing great damage to Korean fishermen and coastal area. So, to predict the inflow of the macroalgae into the Korean waters, we developed the prediction model. Because they move along the current, so we need to international cooperation, especially with the other adjacent country, to predict the model prediction. Yeah, to increase the model prediction. For the harmful algal blooms, we operate harmful algal bloom monitoring teams, including government National Institute, local governments, Coast Guard, fishermen, and public. Especially the public, called the citizen scientists, are helping to protect public health and economy by supporting the red tide forecast. We provide them a portable microscope system for detection. We also developed the harmful algal bloom information system to provide information 3 to 6 days before the occurrence of the red tide. We also operate jellyfish monitoring teams involving multi-stakeholders. We developed the jellyfish report website for mobile, so while you are on the beach, you could take a photo of the jellyfish and then upload it to the website, and you can get this beautiful jellyfish lamp as a reward. So there are tons of photos recorded and submitted to the public database. So the multi-stakeholder approach has enabled a much broader scope of early detection than would otherwise be possible. So without the contribution of the public, so it will be, the data provided will be a little bit delayed. So these activities could contribute to the safe ocean and productive ocean. And this one is a little bit new. I think several stakeholders, including Voice for Consumers, have launched a campaign called Fish Love Band to protect fisheries resources during high fishing season. This campaign provides a slap band, this one. So, to measure the length of the fish to distinguish younger size fish from the adult. The purpose of this campaign is to raise public awareness on excessive fishing over immature fish. So if someone is interested in this slap band, please contact me after my presentation. And younger generation are important. So we are supporting early career ocean professionals in a couple of ways. The KOC and KIOST have held next generational ocean scientist workshop since 2014. This year's event will be held immediately after PICES annual meeting. And also, Co-PICES committee has finally support five Korean ICAPs on average to attend the PICES annual meeting. A good news I heard yesterday was Korean ICAP had their first meeting last month to explore ICAP's engagement opportunity with Korea PICES and PICES and Ocean Decade. So far, we've looked at the Korea's current and potential engagement for the Ocean Decade. The gaps that we have, the limited resources, limited awareness and participants from stakeholders at large, and poor organization of the stakeholders. So here's some solutions for the gap. So we need to enhance the resources. For human resources, empower ICAPs for new ideas and enthusiasm. And for research, by aligning with the national priority, we can enhance the research by aligning with the national priority by harnessing ongoing national projects and by securing new research budgets. And also, enhancing outreach is really important. We can enhance outreach by connection with the local communities. Organization of the stakeholders needs to be improved. So organize the stakeholders and enhance communication among stakeholders. Especially, we need to improve the expert groups integration between KOC and other Korean science and technology society like fisheries scientific communities, and need to improve the international cooperation, especially with the neighboring countries. So I would like to end my presentation with 2 sentences. True running continues until it is put into action, and now is the time to act. So thank you for your attention. I would like thanks to my colleagues. Yeah, these are people. Okay, thank you.
Okay, we now, thank you. We now begin the session 1, the science board session. And our first speaker is Professor Fangli Chao, who's the Deputy Director General of the First Institute of Oceanography in China. Fangli is also a member of the Governing Council here in PICES and has taken also leadership role as a member of the Ocean Decade Advisory Board. He's going to join us remotely through Zoom, so if the technology works, I would like to give the word to Fangli. Yes, we are experiencing some technical challenges, and I don't really have much
of China. I'm sorry I could not take part in the PICES annual meeting in Busan due to the COVID-19 limitation. I hope to meet you all in the near future. So today, my topic will be the intersection of UN Ocean Decade and PICES future in the North Pacific. My presentation including 4 parts. The first will be focused on the intersection and the scientific challenges. As we all know, the UN Decade of Ocean Science for Sustainable Development officially started from the beginning of last year, 2021. There are 7 outcomes for the UN Ocean Decade. They are clean ocean, safe ocean, a protected ocean, productive ocean, healthy ocean, accessible ocean, and inspiring and engaging ocean. Today, my talk will be focused on a predicted ocean because it's quite related with PICES' future. Future means forecasting and understanding trends, uncertainty, and response of North Pacific marine ecosystem, which has been a core product of PICES. And among all processes, climate change and human activities, their effects on marine ecosystem is the core of this project. There are lots of intersections between future and UN ocean decades, including forecasting, understanding trends, marine ecosystem, adaptation to climate change, service to public and governance, science-based solution for sustainable development. To my understanding, the value chain of PICES' future project is from forecast to service and then solutions. Now we analyze one term by one term. For forecast, we have lots of process understanding, research papers and report, but no operational products are available. For service, no high quality products, so it is hard to provide service from PICES to member states. For solutions, science-based solutions are still crying needed for North Pacific sustainable development. The UN Ocean Decade may be a driving force for PICES' future project, and climate prediction is the core for the connection between UN Ocean Decade and future. However, we still face ground challenge in the simulation and prediction of climate system. This figure shows the sea surface temperature bias for all semi-profile climate models. So we can see in the southern hemisphere, the simulated result is 3 degrees higher than observation. And in our forecast, the North Pacific area, this SST bias is about 3 degrees lower. This is not for one single model, it is for multi-model mean. For one single model, the bias could be more than 6 degrees. As we know, El Nino is have a lot of influence, but their sea surface temperature anomaly is just about 1 to 2 degrees. This means our climate prediction and simulation is far from accurate. So in the second part, I would like to introduce new scientific understandings. As we know, the heat content of 3 meters seawater is equivalent to the heat content of total air. So the upper ocean controls the long-term prediction of ocean and climate. However, in the simulation of the upper ocean, especially for the mixed layer depths in summertime, we face ground challenge. This figure on the left is from the data, the observed mixed layer depths, while the right shows the simulated mixed layer depths. We can see there is a lot of difference in high latitude. The other key process with high uncertainty is the ice interaction. Here, we take the momentum flux as an example. As we usually used, the drag coefficient will increase with the wind speed. and the parameter for A and B are totally different for different users. In fact, this means our understanding on this process is not clear. And for high wind speed, the CD drag coefficient will be saturated and even decrease. This is from observation. And this could not be described by this formula. The above two processes, the ocean mixing and the air sea interaction, are both turbulence related. Turbulence is the most important unsolved problem of classical physics. Here, I would like to cite several sentences from Professor Heisenberg. He writes, "When I met God, I'm going to ask him two questions. Why relativity and why turbulence? I really believe he will have an answer for the first." As we know, we lack of vertical mixing in our model, but we don't know where the mixing comes from. Before, all the scientists believe the non-breaking surface wave could not generate turbulence. In fact, this is not correct. In 2004, we discovered the non-breaking surface wave could generate turbulence and play a dominant role in the mixing process of the upper ocean. And we set up the non-breaking surface wave-induced mixing theory. The second example is the wind stress. In our ocean and climate models, the wind stress will follow the direction of the wind. In fact, from the observation, this is not correct. There is an angle between the wind direction and the wind stress direction, and sometimes this direction could be opposite. The reason is also due to the surface wave. The third example is the momentum flux in the ocean side and in the atmosphere side. Before, we believe the momentum flux in the ocean should be less or equal to that of the wind stress. However, from our new observation, the momentum flux in the ocean side could be several times larger than that in the atmosphere. The reason is also due to the surface wave. The fourth example is the sea spray. As we know, sea spray is not considered in our ocean model and climate models. From our observation and model results, we revealed that the sea spray play a key role to enhance the heat flux between the ocean and the atmosphere. The last example is albedo. As we know, albedo is a key parameter in climate system. However, in our climate models, we always take albedo as a constant. From the observations, the albedo have a lot of difference due to different wind and wave conditions. So now I will move to the third part, solutions for climate prediction. Now let's check the model response to the above new scientific understandings. So the first is the ocean model response to the non-breaking wave-induced mixing. The left column is for the South Pacific in February, that means in summertime. The lower panel is from observation, while the middle is from classical model. So you can see a lot of difference between the simulated mixed depths and the observation. And the upper panel is by including the surface wave-induced mixing. We can see, especially in the high latitudes, the simulated mixed layer is quite similar to the observation. Then we check the effects of non-breaking wave-induced mixing to different ocean general circulation models. Here we select the PICES model. PICES model is from AWE of Germany. So from the simulation results, the upper is the simulation error from the original model. We can see in the surface, the sea surface temperature is too high, while the subsurface temperature is too low compared to observation. And the middle is a contribution of surface wave. And the lowest panel is the model bias by including surface wave. We can see the bias is very close to zero, both for surface layer and the subsurface layer. So now we move to our fourth of a climate model. So as I introduced at the beginning, in the northern hemisphere, the sea surface temperature is too cold compared with the observation for all climate models. So here we include the wave effect in the LC flux scheme and noticed this wave effect could enhance the sea surface temperature. And the too cold sea surface temperature bias in the northern Pacific and Atlantic are reduced by about 30%. The too cold tongue of sea surface temperature in the eastern tropical Pacific is a common challenge for all climate models. By including the surface wave-induced mixing, this too cold tongue is reduced by about half. As we know, our original idea is by including more mixing, the sea surface temperature may be reduced, but in climate system, the sea surface temperature could be increased by including more mixing. This mechanism is explained in detail in a JGR paper. The last, we'll check the sea spray effect. As we introduced, the sea surface temperature in the southern hemisphere is always overheating. By including the sea spray effect, about 1.5 degrees will be reduced. So this process can dramatically reduce the climate model bias. By including all these new physical processes, we developed 2-generation Earth system models we call the FIO ESM version 1 and version 2. And we took part in the CMIP 5 and CMIP 6. Our model can reduce the sea surface temperature bias about half, and is one of the best climate models in the advanced CMIP 5 models. The non-breaking surface wave-induced mixing theory was tested by different model groups from different countries, such as the NEMO model, the ROMS model, the GFDL model, and the AVI model. Here, I take the GFDL model as an example. So they compare different mixing schemes for the simulation of the mixed layer depths for the global ocean climate models. So our scheme performs the best and compare with the observation. The last part is a new momentum for PICES. as we know, UN Ocean Decade has 4 kinds of actions, including program, project, activity, and contribution. Among the 4 actions, the programs are much competitive. And the UN Ocean Decade also will set up a series of Decade Coordination Center or Office. This center or office will coordinate a series of programs. I'm very glad to share with you that our PICES family is quite active in support of the UN Ocean Decade. Take one example. So now for the first time, UN Ocean Decade set up 5 DCC, this means Decade Coordination Centers, and 3 is in our family, our PICES families. 1 in United States, 1 in Canada, and 1 in China. And the PICES family already initiated lots of programs and projects. So now the problem is how to integrate these activities, including the DCCs and programs or projects, to support the PICES, especially future remains a grand challenge. So here I would like to introduce our Decade Collaboration Center on Ocean Climate Nexus. So this is focused on Challenge 5. The most outstanding character is this DCC will focus on the modeling and provide service to the global. So of course, we are very glad to provide service to the PICES and the related international organizations. We initiate a program named Ocean to Climate Seamless Forecasting System, called the OSF. So this program will also focus on the climate prediction, and we are ready to contribute to PICES, and we are also highly welcome expert from PICES family to join this program. So my conclusions is as follows. The first, to make a blueprint on integrating PICES and UN Ocean Decade is highly needed. Secondly, we found that small-scale surface wave play a dominant role in ocean turbulence and ice interaction. Thirdly, based on the above findings, some common challenges of ocean general circulation models and climate models are much reduced. A predicted ocean may be a point of a junction for both PICES and UN Ocean Decade. So lastly, our approved DCC, OCC, and OSF program would like to contribute to PICES, especially on services through providing operational climate prediction of the North Pacific. Thank you so much.
Thank you, Fang Li. There will be no questions because this was a recorded talk, so we're going to move to the next talk, which is given by Dr. Jeanette Gan, who is an oceanographer at the National Ocean Administration in the United States. And in PICES, she also serves as the chair of the T-Code Committee. So if you could please start the presentation, this is also recorded.
Good morning, everyone. My name is Jeanette Gan, and I'll be talking about increasing capacity and incentives for data sharing within the UN Decade and strategies to incorporate PICES research into broader international platforms. But first, I'd like to acknowledge my co-authors, Kate Wing, Igor Shevchenko, and Brett Johnson. To give you a brief outline of this presentation, I'll first begin with some background on the decade outcomes and challenges and introduce you to a digital ocean. Then I'll introduce the Ocean Decade Data Coordination Group and a data strategy, and then talk a bit about PICES data and information and how we might connect PICES to wider international platforms. There are, as you likely know, 7 desired outcomes for the UN Decade of Ocean Science. These outcomes represent the ocean that we want, and they include an ocean that is clean, healthy and resilient, productive, predicted, safe, accessible, and inspiring and engaging. This presentation focuses on the accessible ocean outcome. In other words, access to data and information about the ocean. And just as the 7 outcomes outline the ocean that we want, the 10-decade challenges outline the science that we need in order to achieve those outcomes. As Dr. Vladimir Ryabinin has stated, it's all about data, data, data. And therefore, the accessible ocean will likely result from meeting these 3 challenges: to expand the global ocean observing system, create a digital representation of the ocean, and provide skills, knowledge, and technology for all. So why is it important to obtain a digital ocean? Achieving access and quality of data are paramount first steps for enabling the science that will lead to success for the Ocean Decade goals. Just as phytoplankton sit at the base of the food web, data is the base of science. It is literally the fuel that powers the rest of the UN Decade actions. As the climate continues to warm, it'll be essential to obtain efficient access to quality data that will inevitably be used by decision makers, emergency networks, researchers, forecasters, and more. At first glance, it may seem like an insurmountable task. However, the goal is not to have a single data platform that contains all digital ocean data and information. The focus instead is on a collective design and construction of a distributed, multi-component digital network. In other words, connect and bolster all of the relevant existing platforms so that they're searchable from a single point graphical user interface or catalog. And though this may not be insurmountable, it's still a considerable undertaking. So who then becomes tagged to help guide this entire process and ensure that all the relevant needs concerning accessible data are accounted for? In order to help facilitate and guide the work to meet these challenges, the IOC Ocean Decade Data Coordination Group was initiated. It includes Kate Wing, an invited speaker to the T-Code W10 workshop here at PICES this year, and a co-author on this presentation, and Jan Bart Kalawart as co-chairs of the group. The group brings together 25 experts from 12 different countries representing various industries, fields, and stakeholder groups. And together, we will work to reinforce and focus efforts to significantly enhance ocean data and information over the course of the decade. If you're interested in some more information on the group and its origins, you can click on the QR code at the top of the page to link to an IOC page with more detailed description. There are a number of tasks appointed to the group, the broad categories of which include the following: to develop a strategic plan focusing on data types, observing systems, data and information management and capacity development needs, among others, required to address the 10 challenges. To develop a gap analysis and recommend activities to close those gaps. To document and facilitate exchanges of information on ocean data initiatives. And to advise on calls for decade actions and support decade programs or projects related to data. Currently, we're in the process of finalizing the first step, which is to develop a strategic plan or a data strategy. The development of the strategy is sort of like constructing a house from the top down. The strategy house then first begins with a vision. The vision is to have a trusted, inclusive, and interconnected ocean data and information ecosystem that is actively used for decision-making to address the decade challenges. The mission comes next, and it is to create a framework for solution-oriented global digital transformation and fulfill the vision above. That's a significant mission that will take quite a bit of work to manage. So the mission gets further divided into smaller strategic objectives. First, we need to build trust in shared data and information by ensuring it's secure and that it's of known quality and origin. Second, we need to enable an inclusive data and information ecosystem that allows different data types to be made available and combined as needed equitably by all users worldwide. Third, we transition to an ocean-oriented, interconnected, global data space, behaving as a seamless whole with ever deeper interconnection and interoperability. Fourth, we prioritize co-designed solutions that support decision-making to address the decade challenges. And finally, we need to provide a framework that enables decade action data strategies and plans to align. And in order to make all of this happen, many enablers are needed to support this. Those enablers will come from capacity building, technology and innovation, partnerships, sustainable funding, and policy and ethics. Considering there are already currently so many opportunities to access public data from a number of different sources, why then do we really need a data strategy? There are a few reasons, including the fact that, as many of you likely know and have experienced, it can be quite difficult to find and access data, knowledge, and information you need to accomplish a project at hand. Sometimes you know a type of data or information is available, but you don't know where to go or who to ask in order to find it. This can be both time-consuming and frustrating. Additionally, there are considerable gaps in key data sets and regions. For example, only 23% of the seabed is mapped. This is only one of many gaps in our data and understanding of ocean ecosystems across the globe. There are miles of coastlines and open ocean that are essentially blank spaces in terms of data input. Some of these areas are difficult to access or cost more money than organizations often have to get to and study them. There's proliferation of discontinued databases, disconnected databases, and platforms that contain data of unknown quality or origin. Many small pockets of databases and data exist on the internet whereby owners of the data are unknown or crucial metadata is missing. I heard someone say at a recent Decade Data event that they'd rather have no data than bad data, but unknown data is understandably often treated like bad data. Therefore, resources and focused efforts are needed to thoroughly investigate these situations. And finally, there are very limited connections between the many varied different disciplines within ocean science and between data sources themselves. Connections between oceanography, plankton ecology, pelagic and benthic fisheries, marine biology, marine mammalogy, seabird observations, climatology, modelers, forecasters, the list goes on, are all often in their own world of data and information. And we need to better connect not only the disciplines and the people, but the data sources as well. But not all data sources are made of numbers. There are reports and publications that contain knowledge, and new types of data like videos and photographs that need to be accounted for and connected as well. So how then does PICES fit into all of this, since we don't manage any databases and have very few data sets? PICES actually contains a wealth of information as a result of decades of international collaboration through working groups and a variety of PICES projects. Information across the entire North Pacific, information that's not always readily available in the form of raw data, is available in the many types of PICES publications. There are numerous publications and reports on the PICES website, such as PICES science reports, technical reports, special publications, annual reports, decades worth of biannual PICES press articles, and even a few data sets that have resulted from various PICES projects. Additionally, there are books, published manuscripts, posters, videos, illustrations, and more. So how would you go about searching through all of this information to find something specific to your needs? Say you wanted information about oceanography in the Yellow Sea. How would you go about searching for it? Introducing the T-Code catalog. I realize this has been introduced by my co-author, Igor Shevchenko, who has helped develop and take great care of this useful resource, but I'll introduce it again here. You can find a link to the catalog on the PICES website through the T-Code page, or you can go to the QR code listed here on this page and the next few pages. Not only can you search for information from the variety of PICES publications and catalogs that contain information on cruise reports, among other things, and more than 4,000 data sets as well. You can search for information or data in many ways, including a search by broad category, using a map tool, or you can do a basic keyword search. For example, this search for the Yellow Sea came up with a number of cruise reports and other results. After clicking on one of the results, a new page is brought up that looks like this. It contains a brief summary of the cruise report, the year it was done, and a link to where the report is located. Additional relevant metadata is also available on this page. And if you're interested in finding a PICES publication that discusses a specific subject matter, like HABs or marine pollution, you can simply search for it using the T-Code catalog, and relevant results will be returned. I'd like to invite you all to go to the link, search for something, and get to know the T-Code catalog better. However, updates for current records in the T-Code catalog are needed, and it'll take a team effort in addition to creating a culture of better data management from collection to long-term archival and storage. By working together, we can bring PICES data strategies and management into focus with the UN Decade Goals. For example, with the help of T-Code PICES expert groups, can initiate data management plan for products that result from their collaborations at the onset of each new project or group. Additionally, creating metadata record in the T-Code catalog only takes about 15 minutes. And simply by addressing data management needs up front, Together, we can initiate a wave of better data management, metadata management, and information within PICES. So how then do we connect the PICES data, wealth of information, and T-code catalog to the UN Decades digital ocean? One option is to start by updating the PICES data policy to be more in line with the UN Decades goals, and to encourage PICES working groups, study groups, summer schools, and other special projects to handle any resulting data in accordance with this policy. The IOC recently updated their own data policy to align with the decade goals, and as a result, T-code has recently followed suit, and we are in the process of drafting an update to the PICES data policy as well. There are a number of additional clauses and points made by the new draft policy. The particular points align directly with the IOC's new policy that follow the UN Decade data goals. The updates include clauses about the importance of timely, unrestricted sharing of oceanographic data, metadata, products, and services. Discussion on how data, metadata, and products should be accessible, reproducible, interoperable, and freely and openly shared. Suggestions on data management and the preferred use of external data platforms that align with UN Decade standards and goals. Use of those same platforms need to be contained within that interoperable network of information I discussed earlier. And finally, the use of IODE data centers that link to ODIS. And ODIS is another way to help PICES data and information simultaneously reach a broader audience and connect with UN Decade goals. The Ocean Data and Information System Catalog of Sources, or ODIS, is intended to be a framework where existing ocean data and information systems, products, and services will be promoted, where connections between those systems will be promoted and possibly developed by relevant stakeholders. PICES could enter a variety of its own information into this global catalog. For example, the T-code catalog and data inventory. Information on the organization of PICES itself. Multimedia content, including all those books, reports, illustrations, videos, etc., that have resulted from decades of PICES international collaborations. We could even add information about specific PICES projects. ODIS aims to be an online, browsable, and searchable interface for all existing ocean-related, web-based sources and systems of data and information, in addition to products and services. Most of the well-known and more traditional data platforms are not set up to handle non-traditional data types or new data types like illustrations, photos, videos, nor do they generally take or handle publications and reports. Therefore, additional ways to connect this type of information together, wherever it is housed, through a searchable network is needed. ODIS, therefore, will provide an online catalog of all digital ocean data and information sources. In other words, a veritable guide to the digital ocean. PICES is a unique organization. It brings together scientists from 6 different nations and supports numerous working groups, summer schools, workshops, study groups, and more that produce relevant, synthesized information across the entire North Pacific. We may not have a significant amount of raw data within PICES, but the information contained in the many publications as a result of decades of international collaborations is significant. It is with this information that we can add to the growing network of connected digital knowledge about ocean ecosystems and increase the reach of PICES to a broader network. Like I've mentioned before, most databases are not set up to handle more than a number-based raw data types and occasional metadata. And the UN Decade Data Strategy challenges this by recognizing the need to include information and new types of data and knowledge, like indigenous knowledge, video and audio recordings, photos, written reports. With a digital network and a catalog aimed to be used as a search tool for all available digital ocean information, we can connect and access all types of information. And when thinking about constructing an entire digital ocean, it's quite a tremendous task. But expanding the reach of PICES is not that difficult a goal to achieve. There's no need to reinvent the wheel. We just need to create a better culture of understanding data management and sharing, a way to connect through interoperable digital network and leverage already existing and readily available databases and information platforms like PICES. And by improving our management and connections and expanding the reach of PICES, we help to improve digital access to the oceans, taking us one step closer to achieving the Ocean Decade outcome for open access to ocean data. And with that, I'd like to thank you very much for listening. If you're interested in keeping apprised of continued Ocean Decade activities, you can visit the website listed on the lower right-hand side of the screen here at oceandecade.org/sign-up, or you can use the QA code to take you directly there. Additionally, if you have any questions, please feel free to send to an email of one of them listed above right here. Thank you very much, and I hope you have a wonderful meeting.
Well, I want to thank the last speaker for speaking so clearly in this interdisciplinary audience. Our next speaker is Naya Sena, who studied biology at the University of Cape Verde and is now pursuing her PhD at University of Tokyo, studying social sciences and applying it to marine systems. Oh, where is she? Is she here? I think it's an in-person talk. I also want to acknowledge that she is a member of the Early Career Ocean Professional Advisory Panel, right, ECOP. Thank you.
I can see. It's okay. Oh, okay, that's fancy. Thank you so much. Thank you. Oh, okay. Thank you. Oh, wow. Hello. Good afternoon, everyone. My name is Naya, and I am a PhD student at the University of Tokyo, but like I was presented, I am from Cabo Verde, a small island developing state in West Africa. And this is part of my research that I'm doing for PhD. So I'm trying to identify ocean decade challenges, but within the context of small island developing state. How can we adjust them to fit the context of small island developing states? So I think we all know about the small island developing states, the SIDS, and how unique they are, their vulnerabilities, their challenges, and how they are so susceptible to climate change. And most importantly, how ocean dependent they are. A lot of people mention tourism, fisheries, but for people that are from SIDS like me, the ocean has many meanings, culturally, historically, traditionally, so it's very important for us. I guess I need to be more firm with this. Okay, good. And just like many people have talked about the Ocean Decade, the goals, the outcomes, challenges, and so on, I would like to highlight the importance of the motto of the Ocean Decade, the science we need for the ocean we want. Who are we? What are we talking when we say we? We want to promote sustainable development. We want to promote ocean science. But when we say we, who are we talking about? So of course, you've been introduced many times to the challenges, so I will not burden you more. But just to reference that specifically, I'll be looking at the 10 decade challenges. And we have the National Decade Committees. These are multi-stakeholder groups that serve as an extension of the Ocean Decades to the different countries. And so far, and according to the progress report done between, I think it was released in May, we have 28 national committees, and Cabo Verde is right there. And it's the only SIDS so far in having a national committee. So it sounds a bit contradictory that we are looking for the Ocean Decade and we are reinforcing ocean science, and we are not looking or installing national committees in the states and nations that are most dependent on this resource. And let me just share some information that I gathered from the Ocean Decade Progress Report. So about $844 million have been mobilized for funding, and several different programs, projects, and so on. But I took a closer look at it, and if we look at the decade programs, the endorsed decade programs, 84% are done in North America and Europe. I don't think there are any SIDS there. We also have, in terms of projects, North America and Europe count for 80% of the decade projects. I don't think that's where the majority of the SIDS are either. I think it's Pacific and Caribbean counting for the most number of SIDS. And if we look at the activities, the number is slightly better, but still above 50%. So 68 activities, are done in North America and Europe. And I took a look on the report and what they signaled as the main themes by endorsed decade programs. And although some of these topics cover issues that are related to SIDS, there is no SIDS-specific themes. Therefore, and in the context of Cabo Verde, which I'm using as a model case, the objectives of this research is to try to identify the research needs in ocean science for SIDS, to analyze the Decade of Ocean challenges for SIDS, and to contribute to the global knowledge regarding SIDS and Decade of Science. And if you want more information on Cabo Verde, I'm happy to share later, or we can discuss in Q&A. But yes, so I started my PhD in April 2020, so the pandemic and I are best buddies. So I couldn't go to the field to survey the local stakeholders. I forgot to mention that a big part of my research is focused on the communities, promoting sustainable development of communities, but based on what they want, on what are their perceptions, expectations, and understandings. So imagine the frustration of doing this type of research with local communities during a pandemic. You can't. By 2021, I said, okay, I need to find a solution. The travel restrictions were still quite heavy, so I decided to do Zoom recorded video calls with some local stakeholders. This was a good attempt, but it was my second option. My first option would be, of course, to be in the field. And unfortunately, this limited me in terms of close contact with stakeholders at the level of fishermen, farmers, and so on. But I tried to make the best out of it and engage with other different stakeholders that would be available for a Zoom call. So I did 27 semi-structured interviews. This was back last year. And I was basically trying to understand stakeholders' perceptions to determine the ocean we all want, all the stakeholders, in order to determine the scientific priorities for the science we need. And just a quick note in terms of gender, we know this is a male-dominated area, but I tried my best to bring some balance in terms of gender sampling, and I could sample 33 female stakeholders. Not as much as I would like, but considering the field, this was what was possible to do. And I had different types of stakeholders that I could reach out to. Some of them I had already identified, considering that I am from Cabo Verde and I've worked there for a couple of years after my bachelor's degree, so I had already identified some key stakeholders, but others were indicated by whoever I interviewed, so kind of a snowballing sampling. So I interviewed different stakeholders, as I was saying, researchers, academics, NGO leaders. In the context of Cabo Verde, NGOs play a very important role in terms of science production and conservation projects, and ecotourism operators. Before pandemics, tourism was almost 50% of the country's GDP, which is also typical from seeds. So it was important for me to get to ecotourism operators, government officials, environmental activists. And if I look at the stakeholders in terms of their area of action, I sampled 33% people that act in terms of natural social sciences, economy and business 18.5, civic engagement 30%, government and management 18.5. So here are the results. So this is a very simple graph showing the analysis I did on the interviews in terms of references. I used the software in vivo. If you've ever worked with social sciences, quite a useful tool to analyze, to do content analysis of interviews, and it just gives you the number of references you get for certain topics or certain codes. And of course, the codes I used were the different challenges, the 10 challenges. So every time I would find a topic related to a challenge, identified as a challenge for the country, I would code it like that. So for Cabo Verde, as you can see, generally speaking, we will go through them one by one, but the most important one was sustainable ocean economy. And then, just by -1 reference, protect and restore ecosystem. We can discuss about this a little bit more, but let me just say that if this was probably 10 or 20 years ago, this table, I assume, would be very different. Cabo Verde used to be a very radical conservationist type of country where social economic development was not taken into consideration. So it's good to see that now we have a more balanced understanding that we need to protect our ecosystems, but at the same time, we need to promote social economic development. And yes, let me go by them one by one. And if I miss something, please let me know. So I put these tables here not to make your life miserable. I don't want you to read all that, but it's just to give the framework and this method step by step that I used. So not only I used the software, but I felt the need to list each one of the sub-challenges, if I can say like that. I think I will call them from now on local challenges. So, of course, within each challenge, there are different aspects of it. So I listed them and called them local challenges. And the different bars are nothing but the number of references that each one of them has. And obviously color-coded them to help me visualize better. So, for example, if I looked at one of the challenges, the number 2, protect and restore ecosystems, you can see different challenges or local challenges that were identified in the interviews. But we will go by them one by one. So the first challenge, marine pollution. Of course, Cabo Verde has the same challenges as many seeds or many other countries. But I tried to bring one example for each challenge that I thought are relevant within the seed context and within the local context to reinforce and explain this idea that it's important for us to understand the local context and to adjust international frameworks to the local context. So, marine pollution. The local challenge identified was reduce agriculture impacts on marine resources. So these are very, very small islands. The biggest island in Cabo Verde has around 900 kilometers square. So very small islands. And the area which farming is done is very close to the coastal area, if not in the coastal area. So, and another important aspect in terms of the society in Cabo Verde is that most fishers are farmers, most farmers are fishers. So this also reinforces the idea of proximity of these two areas and how they can overlap sometimes. And of course, the wastes produced in agriculture tend to run off and go to the ocean, whether are chemical waste or even solid waste and so on. So I think I chose this one to bring, not only to show the proximity of these two areas, but also how interconnected different areas of sciences are, especially if we're talking about small island states where the space is so limited, so everything is very interconnected. And you can see some examples of citations from the interviews of what was said, for example, from an academic researcher. Fisheries and agriculture are practiced near the coast. From the land to the sea, we have pesticides, solid waste going and contaminating and polluting our waters. So this is a serious issue to be addressed there. And number two, protect and restore ecosystems and biodiversity. Of course, Cabo Verde has had a huge effort in terms of conservation of species, specifically talking of sea turtles, seabirds. Cabo Verde is now fighting to be the #1 place for nesting of loggerhead sea turtle. The conservation efforts have been amazing, and I think there should be a publication soon about the numbers and how staggering they've been. There has been a change in terms of stakeholders' perceptions on what can we do to conserve and protect our biodiversity, our ecosystems. Of course, we need direct action, but we also need to think of other aspects of it, of other sociological aspects. So one challenge pointed was the alternative livelihoods and socioeconomic development as a tool for conservation. This in order to reduce the pressure on marine resources. I brought just some points to help you understand the context of Cabo Verde. The minimum wage is about $120 US a month. Ecotourism is often referenced as a solution, but it's not suitable for fishermen or farmers who probably don't speak English or have difficulties interacting with tourists. So it can be limiting to a certain privileged group of the society, and which leaves people with nothing but extractive activities as an option for income. So the goal then is to promote diversity and alternative livelihoods that will help people have a sustainable and profitable activity and will deviate the pressure that exists on our natural resources. And I wanted just to bring a case that it will be quite transversal to the presentation, which is the case of sand extraction. I have a picture here. I don't know if anyone in the room has this issue in their country, but in Cabo Verde, a lot sand are extracted from the beaches for construction. And although if you look at it, it's not super profitable, but it's what people usually go to when there is a drought or when there is a bad fishing season. So it is a source of income, and it's the most immediate one. And what, of course, this causes is a huge habitat loss and destruction of beaches. And I've mentioned that Cabo Verde is an important nesting site worldwide for sea turtles. And as you know, they nest on beaches, on sand. So it affects different habitats and different species. Sustainable blue food. So, of course, we think about feeding globally and providing food for everyone, but in the context of seeds, this is very critical because we depend a lot on imports. It's one of our characteristics. And the more we can produce food internally, the more independent and less vulnerable we are. But what's been happening in Cabo Verde is that we've been having these huge fishing deals done with European countries or other countries that not only has increased the price in the local markets for fishes, but we have seen that what is costing, for example, for tuna, what is costing us maybe 2-3 euros to buy, in Europe we can buy for €1. And it's our resource and we're not taking advantage of it. And it's creating a sense of food insecurity in the country because people are feeling that they need to pay more. And they're seeing as well the resource getting more and more scarce. So although we have a plan for fisheries resource management, it's a plan that seems to focus a little bit more in keeping the fish stocks and maintaining some fishing deals. It's not much worried in promoting food security for the locals, which is very, very important. And it's an aspect of sustainable blue food. Okay, number 4. Oh, here we go. So, sustainable ocean economy. Diversify blue economy activities, promote local microeconomic development. You can see again the repetition of concepts. These are also linked to protecting ecosystems and using creation of alternative livelihoods as a tool, not only to protect and conserve ecosystems, but also to promote sustainable ocean economy. And this is to show as well how the challenges are linked and how promoting one helps develop the other. And it is very important, yes, that we have different activities, not only extractive activities, and that we break out a little bit from the traditional so-called businesses and blue tourism or blue economies, and that these activities are benefiting especially the local communities. Of course, we understand the importance of macro economy, big companies, but if the local people are not benefiting from this blue economy, then why are we doing it? So the locals feel the need to have more economical power, to be included in these economical plans to promote their own development. Ocean climate nexus. So this is a very interesting thing that relates back to the fact that we are small island states and all the environments are so close to each other and they're interconnected. So it's very important, as has been identified, to invest in transdisciplinary research. We have the SEAS concepts, the social, ecological, environment systems concept of future program, and it shows that different areas and scientific areas are affected by climate and climate change. Just to give you an example, when we were talking about sand extraction, when you remove the sand from the beach, something that happens often in Cabo Verde is that the watersheds are contaminated, the fresh watersheds are contaminated by seawater. And for example, with climate change, and if we have sea level rise and we don't have a sand to protect the beach, you can imagine what happens in the coastal area in terms of coastal erosion. And it seems that with climate change aggravating, the periods of drought in Cabo Verde have been increasing. We've been having 2-3 years with no rain whatsoever. Luckily, this year has been raining a lot, a little bit too much, but it was before of 3 years of no rain. So when we have these long periods of droughts, farmers decrease and fishers augmentate. So people do less farming, obviously, and do more fishing, which increases the pressure on marine resources. And when the fisheries is not going well, or even doing fisheries, people tend to find other extractive activities to do. So here it shows the link between all these areas, the transdisciplinary, and the need that we have for transdisciplinary research and transdisciplinary action. Community resilience. So, of course, there are traditional definitions of resilience and community resilience, but it was very interesting to read the interviews and to see what people would refer to when they were talking about community resilience. And one important part is the participation of communities in decision-making processes, yes, but in management plans and actions and in business investments. So this is not my saying. These are the local stakeholders affirming and asking to be included effectively in these activities, not just as a more consultative body, but as a participative, active body of decision-making processes, management, and business investments. Ocean observations. So, Cabo Verde, and we mentioned this, I remember in one of the workshops we talked about parachute science. So Cabo Verde has to be one of the top places for parachute science that I know of. I'm not saying that there's not ocean science done in Cabo Verde, there is. It just has been transported somewhere else. And the local researchers, local stakeholders, local students like myself, we don't have access to it. And we don't benefit, or we cannot even use it to promote our own sustainable development. And this is not a problem or an issue of those who do parachute science alone. It's also a matter of attitude of our government bodies, our universities, and the local scientific body as well, on how we can stop this and promote scientific knowledge done locally with local, even with collaborations, of course, but in a way that whatever it's done in Cabo Verde benefits the country as well. Capacity, I skipped to number 8 because there was no reference, but I will discuss it later. I will not completely ignore it. It will not have a double rejection. But yes, number 9, capacity development. I wanted to bring this case because it was mentioned in the interview, and I think it's a very important case to share. These are the guardians of the sea. These are fishermen, and they have been trained by this local NGO, Mayu Biodiversity Foundation, to monitor the oceans in different ways. First, sightings of megafaunas like seabirds and dolphins and so on. So they receive a training in identifying the species, and they have a note book that they take with them every time they sight and they see one. And they use GPS to take the locations of where around the island they have seen it while they're doing their fishing activities. They don't go out just for this. While they go every night doing their fishing activities, they do this. And they also monitor for illegal fishing activities. Of course, they don't have any authority, but they report to the local authorities and to the local NGO once they see any illegal activities done by foreign boats or national boats. And this is a very important case that I wanted to bring, that capacity development can be done in different levels, researchers, activists, and so on. But I wanted to reinforce the importance of capacitating the primary users so they understand the value of the resources that they have, because ultimately the conservation and the sustainable use will be done best by them. We can only suggest plans, we can come with our theories, but they are the main actors. So it's very important. That's why it's very important to capacitate them as well. And 9, behavior change. So behavior change also can be done at different levels. Of course, we can talk about the general population and how we should educate in terms of environmental issues and ocean issues, the local population. But we also need to look at the other stakeholders and how they should change their behavior. So I was very pleased while analyzing the interviews to see the reference done to these different stakeholders and how they should change their behavior in terms of ocean science and their relationship with the ocean. So, government should have more concern on environmental issues and not just political and speech-wise concerns, but effective actions and changing and programs and fundings and so on. And academia, we have 2 national universities in Cabo Verde and a couple more privates, but there is only 1 campus for marine science that was done with the collaboration of Huascal. So we need more for a country that is so dependent on ocean. All universities should have an ocean marine campus, a marine science campus. It should be our main target. NGOs are now changing their attitudes in Cabo Verde in including community development as part of their agenda, but for a long time, they were very and solely focused on conservation. So this is still an issue that they need to promote environmental education and be a key actor in disseminating and communicating science and ocean needs to the local communities. And finally, scientists as well. Whether you are integrated in an NGO or working at the university, it's important that scientists simplify but also amplify scientific communication. So getting out of these conferences rooms and talking the language of local communities, trying to understand them and simplify the language. So yes, so going now to discussion and conclusions. This is, as far as I know, the first assessment of UNDO challenges based on seed stakeholders' perceptions. I hope there's more, and this is a false statement, I really do. The top challenges, sustainable blue economy, protected ecosystem, behavior change, are crucial. So for me, that I've graduated around 2011, 12 from the University of Cabo Verde, and the scenario 10 years ago was very different. The word was conservation, 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 which is very important. This is the main resource that we have in Cabo Verde. People go to Cabo Verde to enjoy our beaches and see our marine biodiversity. But we have people there, people that need to make a living, not only to survive, but to thrive and be wealthy. So we need to make sure that we promote a sustainable blue economy and that we change our mindsets and our behaviors in different levels. Challenge 8. It's a very important challenge, digital representation of the ocean. The former talk was about that and how important it is. So I wonder why no one referred to it in the interviews. Is it because we still, at SEEDS or maybe at Cabo Verde, we have such basic needs that are yet to be met, so local stakeholders don't perceive it as a real priority? Or is just a lack of knowledge from the stakeholders? We don't know. It needs further research, or maybe I need to amplify my sample, but yes, it's interesting that there was no mentioning about it. And it seems that within SEEDS context, marine and terrestrial environments are closely and particularly linked, of course. We see so many crossings in terms of marine pollution, agriculture with fisheries. So it's very important to invest in transdisciplinary research and transdisciplinary action. Reducing the pressure on SEEDS, marine and coastal resources, seems to be the big challenge. If I could sum up one big challenge, I would say we need to take the pressure off the marine and coastal resources by whichever means, whether to create different livelihoods, whether is to collaborate with other countries in finding different solutions, but the pressure has to come off. And finally, I think I cannot see it, but it's related to the ocean we want, right? The science we need for the ocean we want. The local stakeholders have to be included when we say we. Who are we? Their perceptions, their wills have to be included. But before I finish, I would like to point to something else missing other than challenge 8, the gender lens. So In terms of the Cabo Verdean society, we have a lot of monoparental families, families that are led mainly by women, whether because they're separated from the father or the father is completely absent. But unfortunately, this is the reality of my country. So women are not only raising the kids, but providing financially, educationally for their children. And none of the stakeholders, including the women that were surveyed, mentioned any gender aspect within ocean science or the challenges that we face. And women are part of it as scientists, as fishmongers, as sellers, restaurant owners, and so on. So it's very important, and maybe we need to include gender lens as another challenge itself, or maybe a transversal topic that we should evaluate all challenges, but it's definitely important, and it might be uncomfortable, but it's a necessary topic, and we need to have more balance in this matter. So, finalizing. Oh, come on, it's the last slide. So, future actions. Similar assessments are necessary in other seats. We are trying to create this global knowledge network. So, of course, this is just one seat out of the 50-something that we have. So, we need to replicate this or improve this method and use in others to try to assess what's happening in other seeds and understanding very well the local context. The global and international frameworks serve as the guidelines, but we need to understand the local context. And we need to increase the number of programs, projects, and activities Hundos is doing and endorsing in seeds. It's very important. And why not then create a seeds targeted call for action? Maybe we can do some sort of a targeted funding, but these are just suggestions and ideas, and I would love to have more suggestions. So now the challenges is for you, the audience, since we are talking so much about co-designing and collaboration and what can we do. So PICES, Windows members that are here, how can we collaborate with seeds? How can we do, and how can we integrate these very fragile and vulnerable states in the science we do? Thank you.
Thank you. Thank you, Naya, for this inspiring talk. And we have an in-person speaker, and so we'd like to have questions from the audience.
Easy questions, please. Oh.
Yes. Heliot, 1 second.
Thank you so much. Sorry.
Oh, sorry.
No worries. Thank you so much for the great talk. I wanted to ask, because the issue of parachute science is one that I am acutely aware of as well, if there were some examples of successful scientific collaborations in Cabo Verde that are already doing these engagements that you might be able to highlight for others to learn from.
Oh yes, of course. There is a lot of good scientific collaborations done in Cabo Verde. With sea turtles is a staggering example, because the number of nests and reproductive females that are tagged every year are just increasing every time the National Committee meets. With seabirds as well, a lot of good work has been done, and we have some endemic species as well there. So yes, there's great collaborations with the University of Barcelona, the one that I'm more aware of, but there's also with some German universities, so there is. But maybe in terms of social economic development or sustainable development, we're still lacking some work. But yes, thank you.
Hi, Naya. I'm Karen Hunter. We've met on Zoom several times. I'm the vice chair of the Human Dimensions Committee, and really appreciate you coming and giving us this talk on your work. I don't really have a question, but sort of maybe you've inspired me to think about how all of us think about our own challenges in our work. And really, the way you phrased a lot of this for me was really our challenges are the solutions. And so we're talking a lot about culture change and understanding solutions in this environment for this meeting. And I've been really inspired by the talks this morning to really reframe my language to start thinking more about solutions versus challenges. And maybe that would just be helpful for some other folks in the room. so that we can sort of move towards together. So thanks for the inspiration is what I wanted to say.
Oh, thank you. Thank you. We're going to change the name from challenges to possible solutions. Yes. Thank you.
Are there more questions on this side? I guess I did have one question. The concept of the sustainable blue economy, of course, is also connected to the well-being of the people that may want to shift from an extractive economy to one that is more sustainable. During the surveying process, did you get any hint of what would be potentially viable sustainable blue economy? Because obviously this is not an easy transition.
It's not an easy transition, and it's also related sometimes to the level of education of those involved. Luckily, I managed to go to the field after the restriction, so I went to the field twice and collected different types of data. But what the data field showed me is that in these local communities, the level of education is really low. Most of the people I sampled had no education or only elementary-based education. So I think that it can be a barrier, but it's not one that it's impossible to go over. But maybe I think Cabo Verde should start investing as well in things like aquaculture. We have some species that are quite, that can be used in aquaculture, not only for fish, but for example, aquaculture of seaweeds and so on that we can use and transform there. One of the big contributors for the Cabo Verde GDP in terms of exports is canned fish. It's almost 45%, if I'm not mistaken. So, but these companies are owned and run by foreigners. So why not create local fishermen associations that can catch and transform their own fish and sell it to the international market? So open probably microcredits and other processes that can facilitate local associations to be more autonomous and productive.
If I may offer a comment, you know, one incredible value that these science and actually more than science, you know, even innovation networks that we have could bring is to unlock some of the big investment funds that are being deployed for countries like Cape Verde, and maybe work with local entrepreneurs to make them competitive and have the backing, both in science and engineering, to actually pursue those new opportunities.
Yes, for sure, for sure. Thank you. Thank you. Oh,
yes, Stephen.
Thank you, Naya. That was an excellent presentation. So I'm going to be talking about SmartNet program later today. And one thing that we have as an objective, of course, is to reach out to and work with, collaborate with, co-design activities with SIDS. And so my question is, you know, it's great you're within the PICES community through University of Tokyo, but how do we make those initial connections? How do we have, you know, develop those relationships initially with SIDS, least developed countries, and other communities? Because it's a challenge.
It is a big challenge. That reminds me of a speaker from yesterday in the workshops that we have. She's from the Mauritius. I don't know if she's here. And hi. And she was mentioning how lucky she was because coming from SIDS, we are very limited in terms of opportunities. And often our perspectives as local stakeholders are not taken into consideration because there is this big barrier between us. So maybe an aspect that we need to create is how do we reach to these level of stakeholders, to the local, to the freshly graduated from SIDS University. How do we reach out to them? Maybe we can have fostering programs directed to these universities. Maybe we can have internships for even high schoolers to start fostering ocean science in these places from a very early age. Because what I lacked in terms of technical capacity compared to my, let's say, Japanese fellow colleagues, I had abundant local knowledge of the reality, of the importance of the ocean, of the different uses. So this is valuable knowledge. We call them local knowledge, right? So let's create ramifications and strategies to get to the local knowledge and promote them. And so I think we can bond easily. Thank you.
It sounds like we have the beginning of an ECOP ambassador program almost.
Yeah.
Are there other questions before we break for lunch? Well, I want to just give another round of applause. Thank you so much for the inspiration. Please return at 2 p.m. We're going to start the afternoon session. Thank you.
Welcome back, everyone. So we're continuing with our S1 session. It gives me great pleasure to introduce the next speaker, Emmanuel Di Lorenzo, who's at Brown University and has been so active in PICES for so many years, is the co-chair of the POC committee, I have it, and will give us some inspiration here. And I would say he's a PICES influencer.
Just one moment, I have to set up the screen thing here. Second. Okay, we can bring it on the main screen. Okay, great. Thank you for having me here. And today I am not going to talk as a scientist, but I'm really going to talk as the chairman of Ocean Visions, which is a nonprofit, talking about how we're trying to go about co-designing climate solutions under the UN Ocean Decade. And for this reason, let me just introduce Ocean Visions. Ocean Visions was established in 2019 by a group of research institutions, mostly in the United States, who made a pledge to really accelerate the transformation of science and engineering to solutions that were practical and also equitable. And in doing so, they recognized that it was important to actually partner with impact accelerators and other groups like NGOs that can actually help research institutions deploy their science for solutions. And so the Ocean Visions is organized with a research consortium that you see on this side of this slide, and then an acceleration and impact partners that are on this side. And then the nonprofit really sits on top of it and tries to essentially make sure that there's coordination between these two groups. And why do we want this type of connectivity? Well, the idea is that we're trying to develop an ecosystem for ocean solutions that can actually accelerate the connection between the various stages of deploying solutions, which are the research, the development, and deployment. And so this schematic here sort of shows the path where we have the researchers here, and then the innovation ecosystem over here for the development of solution, and then, you know, the investment component to actually deploy these solutions and scale them with venture capital, not just funds and so forth. Now, with the beginning of the decade, this concept of an ecosystem for ocean solutions became sort of appealing, and so we thought maybe we could scale this up with other international partners. And so last year, or well, 2 years ago now, we submitted a proposal to the UN Ocean Decade to establish a global ecosystem for ocean solutions together with many partners, among who is also PICES. Now, the goal here, as it's stated on the proposal, is to establish a vibrant, multi-sector community to co-design and co-deploy equitable, durable, and scalable ocean-based solutions for climate change and the ocean grand challenges. And before I dive into how this ecosystem works, let me just acknowledge some of the people that some of you may want to contact. First is our international program director, Dr. Leonardo Valenzuela Perez from Chile, and the two co-chairs of the Science Steering Committee, Fiorenza Micheli from Stanford and Anna Zivian from the Ocean Conservancies. So, how does the GEOS ecosystem work? What is the idea behind it? At the very basic level, the ecosystem is composed of three components that are interactive. The first component is not new to this group, and it's really the network. And the purpose of the network is to convene a multi-sector and multidisciplinary community. And here when I say multi-sector, I mean not just researchers like us in science and engineering perhaps, but also people from industry and so forth. The next pillar is this idea of convening task forces where we take these experts and we put them together to sort of co-design system-level solutions to the grand challenges. And what I mean here is really to bring people together to be the think tank of how do we deploy solutions that are more than just, you know, one startup or one solution here and there. How do we design solutions, for example, to removing carbon dioxide from the atmosphere? And then the third pillar of the GEOS ecosystem is really the GEOS innovation engine. And the goal of this innovation engine is really to act, to prototype, accelerate, and fund, you know, the solutions that we're interested in. So with that said, let me just spend a few words to explain these different components. I think on the network side, we're very familiar with what the networks do. They host summits, and so in fact, in 2021, we hosted the first International Geo Summit that was hosted on 5 international campuses, and I'm happy to report that 25% of the participants were early career ocean professionals who organized about 7 of the sessions. But the other important aspect of the network is also to put together groups of experts that can be accessible on demand to help the development of solutions in certain areas where sometimes you don't have enough capacity in terms of science and engineering. So moving forward, let's talk about the co-design process. So GEOS is focusing on trying to advance system-level solutions in 5 themes. The first theme is ocean-based solutions to the climate crisis, and here really is mostly focused on how do we solve the carbon problem. The second one is equitable solutions for coastal communities. The third is ocean human health. The fourth is marine circular economies, and the fifth one is sustainable blue foods. So how do we plan to design these system-level solutions? Here, we're going to experiment with the model that has been successful for ocean visions in the United States. And it's the idea to develop solution roadmaps. So what is a solution roadmap? Here's an example of something that Ocean Visions published a few years ago of ocean solution roadmaps in the area of removing CO2 using ocean-based processes. And here there are 4, for example, pathways for removing carbon dioxide from the atmosphere. One, for example, here is macroalgae cultivation. So here the idea is that we can grow forests, of phytoplanktonic forests, or even kelps in the open ocean, absorb CO2, and then sink these forests in the deep ocean. Now, this is an appealing idea, but how do we go from where we are today with the technologies that we have and the understanding that we have to a tomorrow where actually we can implement this type of technology for removing carbon at scale? And so the roadmaps are intended to essentially articulate what is the path to bring us from where we are today to where we want to be in terms of deploying these technologies. And in doing so, we want to articulate, for example, what are the research gaps and also what are the innovation gaps that we have to overcome, identify priorities and so forth. So these roadmaps live digitally and are constantly updated by the community of practice that have developed them in the first place. And so they provide essentially a place where there's a common consensus about what are the priorities to advance solutions in certain areas. And so our plan is to develop similar solution roadmaps for other themes that were listed before. So, of course, once we have these solution roadmaps will inform and energize the innovation engine that will act. And here I want to spend a few words to introduce the innovation engine, which is deployed through one of our implementing partners, which is called the 1000 Ocean Startup. This is essentially, it's a global coalition of accelerators, venture funds, and incubators that have come together under the decade and pledged to develop 1,000 startups by the end of the decade. And I'd like to just run a short video about this.
We are the 1000 Ocean Startups Coalition, a coalition of competitions, incubators, accelerators, matching platforms, and venture capital funds across the globe, supporting innovation to restore ocean health and contribute to UN Sustainable Development Goal number 14, life below water.
We help these ocean startups achieve their full potential by bringing them needed expertise, networks, mentorship, visibility, and funding.
Our coalition comes together to create synergies and learnings to maximize the impact of our ocean innovation ecosystem.
Our mission responds to the transformation of a sustainable ocean economy.
Recommended by the Ocean Panel and the program guideline of the UN Ocean Decade.
The ocean is the blue lung of our planet and the main regulator of our planet. It both feeds us and inspires us. Yet, activity as humans and societies has undermined this very ecosystem on which most of the life on our planet depends. The ocean's ability to function and its biodiversity are falling at an alarming rate, suffering from multiple forms of pollution, over-exploitation, and climate change.
Addressing these immense and urgent challenges requires innovation to drive rapid systemic change.
We need to reinvent the status quo and propose fundamentally more sustainable and efficient ways to produce and consume.
In doing so, we will create economic and social opportunities
driven by businesses which can be funded by private capital
and therefore scale their solutions rapidly.
This is critical as time is running out.
The good news is that it is possible, and we hold the keys in our own hands.
Okay, so this was just a little inspirational video, but what are the main actions that we need to take? Well, the first one that we can do using these roadmaps is to essentially mobilize new funding for research and innovation. Traditionally, investing in ocean innovation has been risky because, you know, the ocean is a complex place to work in. And so the idea is that these roadmaps, by providing a consensus kind of view of the critical technology, can actually also inform the investment world. And the second point here is that once we have this new funding, we can then deploy pilot projects that can also be run by these startups to actually test these new technologies and solutions that are not just technological in nature, but can also be social science in nature. And then the third pillar is we also have to measure whether all the things that we're doing are actually having an impact, a beneficial impact on the ocean innovations. And so I'd like to go through these pillars briefly. And the first thing that I want to say is that this model of developing these roadmaps has been quite successful, for example, in the context of these ocean carbon dioxide removal roadmaps. And in fact, we managed to mobilize over $20 million of funding that was released in 3 research calls that were essentially targeting different critical areas of research and also innovation. And you know, for people like us, for example, I know that there are a lot of modelers in this room, and one of these funds was actually for modeling the CO2 cycle and trying to understand if we have technology to store CO2 in the ocean, how can we measure it, realistically, given that we have all this natural variability in the ocean in terms of the CO2 cycle. So this is really a plug also for people that are in science and engineering like us to figure out how we can contribute to this sort of innovation. And our goal and our plan is that hopefully using this approach, we can also mobilize or at least access new funds that are becoming online. Last year, or 2 years ago, I don't remember exactly, but at COP26, there was a release of a new $10 billion fund that was really for supporting sustainable economies in the global south. And so hopefully by co-developing these roadmaps with partners in the global south, we can also unlock these type of potentials. So the next phase, as I say, is pilot projects and new startups. And here's an example of a startup that was funded through this process. It's called Running Tide. And this startup is actually piloting the idea of growing macroalgae forests, in particular kelp forests, in the middle of the Atlantic, and then sink them in the deep ocean. And of course, as we invest in this pilot, what we also do is we partner these startups with a group of experts, a panel of expert scientists in engineering that can actually evaluate and advise these startup projects. And in particular, on things like, what is the impact of putting this carbon in the deep ocean? How is the marine ecosystem going to respond? How about the ocean currents? Are the ocean currents, do we have to consider their impact as we try to sink this carbon? So these are all challenges that actually require scientists to be involved. And here I mentioned one of these startups, but the idea is that there are other startups that are coming online. And in particular, we can also help these startups, access additional fundings. For example, there was a release of the X Prize, which is $100 million for carbon removal. And right now, we have this launch pad, which is essentially advising and supporting startups that are trying to compete for the Carbon X Prize with solution technologies that are ocean-based. As I said, of course, we have all this startup world, innovation world that is coming online, but we also need to measure, if these startups are having an impact. And to do so, with the 1000 Ocean Startup last year, actually this year at the Ocean Conference, we released something called the Ocean Impact Navigator, which is essentially a new impact measurement framework for the ocean innovation ecosystem. And I just want to give you some example of the type of metrics that we've developed to measure ocean impact. There are essentially 6 metrics that this framework measures. 3 of them are connected to direct ocean health and are listed here in blue, 1, 2, 3. And one is sustainable managed ocean resources, a clean ocean, thriving and restoring marine habitats. The other 2 are really directed to the climate change challenge, and in particular, number 4 is really about, does your startup contribute, for example, towards achieving the 1.5 goal of climate? And then the other one, number 5, is about resilient coastal communities. And then we have number 6 metric, which is really more across all of them, which has to do with the positive impacts on socioeconomic outcomes, which include both well-being and also equity. Now, I'm not going to show you the actual technical framework, but the idea is that there is a technical sheets that we can actually deploy to measure, more accurately all these different elements. So with that said, I gave you sort of a quick example, or at least an overview of this GEOS ecosystem and how it's supposed to work. And now I just want to mention a few things about what are some of the GEOS projects. Well, one of them is, in fact, the Ocean Impact Navigator, which is this measurement framework. And we just released the first phase, which is really developing the framework. But the next phase is we'll actually try to implement this framework more widely. And the advantage that we have is because there is this global coalition of accelerators and venture funds, we hope to leverage that to actually make this a standard for going forward. The second project that was endorsed more recently is called Cities. And Cities is really about coastal cities that are trying to develop resilient strategies to sea level and climate change. And I will talk more about this in a second. So the Cities project really is really focused on the GEOS theme too, which is equitable solutions for coastal communities. And the idea behind it is that we can actually bring many cities around the world to share solutions, with each other to sort of understand how to better tackle sea level rise. And before I go into depth, I just want to acknowledge the program manager of Cities, which are listed in this page here, Theo and Lisa and Sarah. And these are actually early career ocean professionals. And they're leading this incredible effort. And in particular, Cities is focusing now on 5 regions that are shown here in this map, because obviously going global immediately is not something that is feasible. And in these different places, they're essentially running workshops and connecting with stakeholders, and so all the things that a lot of us have done, perhaps. So going back then, the first goal of Cities is really to bring stakeholders from these major cities to declare their alignment to share their solutions to sea level rise. And in fact, they released a declaration from mayors from around the world, pledging to actually join this effort. And this is actually a mayor from one of the cities in Japan, which is one of our PICES country. So this is step 1. And then step 2 is to collect the available knowledge and develop shared best practices that can inform national and international adaptation policy. So that's sort of the goal of Cities, and we can perhaps summarize these 2 goals with these 2 bullets here. One is the community science and engagement, and another one is adaptation public policies. This particular phase of City will end in 2023. And so we're already thinking ahead, what's going to come next. Now, if we look at these 2 bubbles, these 2 bubbles are essentially building blocks of an equitable and scalable solution roadmap for coastal resilience. But obviously, there's a lot more that needs to be done. This is not sufficient. And for example, we heard this morning of the important role of sustainable blue economies for some of the small island states. And in fact, one of the building blocks that we have identified is called equitable coastal economies. Essentially, we need to develop solutions that fit in the coastal solution economy so that it actually improves the well-being of people. Now, these roadmaps that are listed here for the coastal resilience are focused on social equity and justice, but we also have technological roadmaps, And the two that we have identified here is one, developing observing system for the coast and people that are meant to improve human health. And here health is thought really more widely, right? We always think about the physical measure like sea level, but people at the coast, especially in underrepresented countries and underrepresented communities, worry about air quality, water quality. And so these are actually part of the observing system that we need to develop to actually create a resilient community. The other aspect here is to develop modeling and prediction data and tools that can support, of course, different types of planning. Going forward, though, it's also important to recognize that the development of tools and policy cannot happen in isolation, and communities also need access to expert networks so that all these frameworks and tools don't come in a vacuum, but come, with the expertise. And in addition to that, we also have one roadmap that is about to building capacity, expert capacity in the end users themselves. We cannot just go there and always try to do things for everyone else. So with that said, there's one last roadmap that I forgot, which is developing these decision-making frameworks for optimization. What I mean here is that, when decision makers at the coast have to take decisions, often they have to have consideration that are not just physical in nature, for example, flooding and sea level rise, but they also have financial consideration, equity consideration. So how do we model those together so that we can actually optimize decision with all these different metrics in mind? And this is an area actually of science that is, is in great need of development. We don't really have it yet. So given the complexity of developing all these roadmaps together, what we thought to do in the United States is to launch a pilot where we would bring 20 or 30 communities, underrepresented communities, to attempt to co-design and deploy a shared set of solution roadmap for coastal resilience. And this pilot has different goals. One first goal and step is to clearly articulate the coastal solution challenges that are shared at the national and regional scales, and also importantly, identify processes that could help develop a community vision. And what are the values for adaptation? And the community vision for what the coast we want, we heard it this morning, is really important because that varies. Different communities have different visions for their coast. And that's the first starting ground to really, and really it falls under the roadmap of community science and engagement. The second step is really to co-develop the next generation of modeling and prediction and observing system tools that are at the scale where people live and make decisions. And I'll give you an example shortly, but for example, in the United States, we have a lot of coastal observing systems that are very efficient in observing the ocean at the coast, but a lot of the communities actually live in the wetlands where we don't really have observations. So to this end, actually in the United States, we held a series of what we call coastal solution workshops, where we went around the different coasts of the United States and we collected a series of case studies of where research universities were actually working with local coastal communities to develop solutions for observing system and modeling system that would inform decision makers. The third step here is that we want to co-design also shared workflows where tools, resources, and processes are integrated within the human infrastructure for planning coastal solutions to climate. And what we mean here is, again, that often we have a lot of tools that are out there and could potentially help communities, but communities don't know how to access these tools, don't know which one to pick, don't know how to use them. And so we need to provide communities also with the human infrastructure of the expert networks, the practitioners that could actually make those tools make sense. And at this regard, in fact, the Center for Sea Rise Solution is actually developing a national community of practice that will serve, hopefully, as the glue that brings the tools and data into the proper context, and in doing so, advance the planning and implementation of solution actions. Moving forward, the last part that we hope to accomplish is to leverage these roadmaps to engage and mobilize investment capitals, as I said before, and also federal funds from Congress to activate these coastal communities and their supporting expert networks. And just this year, we had some initial success in doing so. And in fact, in the state of Georgia, we were able to leverage some of the senators of the state and receive an earmark to actually start with 4 pilot communities in Georgia, this sort of process of developing these roadmaps. And the idea here is that we will do this with other communities around the states to bring, a core communities of maybe 20, 30. And before I end, I just want to give some examples of the work that is going on in these coastal communities of Georgia. As I mentioned earlier, in terms of observing system, what you see on this map is essentially tide gauges along the coast, the east coast of the United States. And, sea level rise and flooding is a real issue along the east coast of the United States, but most of the people are really located across the ocean land and nested within these complex wetlands. So this is the city and port of Savannah. And so you can see that in this region here of the city of Savannah and their communities, there's only 1 tide gauge. Obviously, that is not sufficient data to plan against flooding and sea level rise. And so in this community, what we did is we launched a project called the Smart Sea Level Sensor, where a set of engineers from Georgia Tech developed cheap technologies, cheap sensors that are wireless interconnected, and now we have a coverage of water levels all across this area. And now this water level network that is at the scale of the city was not just brought in by the scientists, but actually was co-designed and deployed with the local communities and stakeholders. And in fact, most of these sensors were built from students in high school and are actually adopted by families who actually maintain the sensors in their backyard. And this network is currently growing because, as I said earlier, people are interested in air quality and other measures that really is contingent to their well-being. And so this is happening right now. We also develop other community engagement strategies that really bring also the elderly to actually transfer their knowledge and contribute their knowledge. And this is an example of what we call the map room, where citizens come and draw essentially their knowledge of their flooding patterns, what they have experienced over the years. And so we collect that knowledge and then we reflect it back to them. Another important aspect is also to build capacity within the end users. And so we also could develop with some of the decision makers some of these tools, like in this case, this is a portal that helps the city of Savannah monitor their bridges, because sometimes if they're touched by salty water, they have to go and maintain them. And then last, we also developed a modeling component and forecasting component with the prediction system that essentially provides 3 days forecasts, which was used in the last 2 hurricanes, successfully. So all these, exercises provide insight in these roadmaps and elements of these roadmaps, for one particular community. So, of course, the idea is that we want to use this approach, but bring together pilot communities from other places to also co-design these shared roadmaps together and use this as a living database for how we can actually advance together solutions. Now, as I mentioned earlier, developing a picture of roadmaps like this for the globe is going to be extremely challenging, if not impossible, and there's no one organization that can do that. And so the idea is that perhaps, different programs under the decade, different projects can actually contribute, independently to different bits of this important puzzle. And so in saying that perhaps this road mapping exercise could serve as a mechanism for really co-designing solutions across different decade actions and really be cooperative in going forward. And because of that, to this end, just this year, we launched one of the US, actually the only US collaborative centers for under the decade. It's called the Center for Ocean Climate Solutions, which is hosted in Atlanta. And the idea is that the center will develop as a resource a digital platform to host these roadmaps and allow different programs and different decade actions to contribute to this particular solution strategy of co-design. I want to end here. So I spoke about 2 of the projects that are ongoing, but there are other projects that are currently being developed. And in GEOS, we also care very much about the younger generations, not just the ECOP, but even the people that come before ECOP. And one incredible way to reach the younger generation these days is through gaming. They're always on gaming computers. And so by partnering with another implementing partner called Stride, we are currently developing a Minecraft world that really sets a whole bunch of challenges in how we create ocean sustainable cities. And believe it or not, this gaming is quite successful. And I just want to leave you with a teaser closing my talk about this Minecraft world.
Welcome to Rehab Lab, a newly formed sustainable ocean city. Come join our team of experts who've dedicated their lives to nurturing and protecting our oceans. Your first challenge is taking on the battle against plastics in our waterways. Guide the plastic recovery boat through the estuary to collect all the plastic heading into the ocean. You'll learn about the most common plastics removed from the water and how we can prevent them from getting into the water again. On your way back to the lab, rescue a sea turtle and bring it back for emergency care and rehabilitation. The next task is to collect mysterious pollution in the water that is threatening our entire marine ecosystem. Collect all the pollution to restore the ocean quality and deliver samples back to the lab. You'll learn the source of several types of ocean pollution and how to prevent it from coming back in the future. Even though we moved as quickly as possible, our coral reef has suffered serious damage.
I guess the audio is not very good, but here the challenge is about building an ocean floating cities using technologies that are actually realistic, like, for example, wind energy, wave energy, and other sources of food. And so the students will have to each student will have a challenge of developing their own cities, and then, there's going to be a competition. So anyway, this was just maybe a little bit too much in PICES to show you a Minecraft world, but I want to thank you for your time, and I hope that you will engage. Bye.
Okay, and the next presentation is recorded. It's by Gennady Kantakov. Shall we repeat plastic research? Gennady is with the Far Eastern Ecological Center in Russia, and he sent an email with a comment about his talk. He says, P in my slide with the Gulf of Alaska map and table means pellet, not propylene. And he says, good luck and have a nice meeting.
Hello, PICES team, and I would like to present my small talk, Shall we repeat plastic research? Of course, we will speak about Pacific Ocean. Let me say few initial remarks. We will talk about plastics in the water, ocean mostly, not biota and sediments, at least for now. Yes, plastic included micro and nanoplastics, but primary interest in talk will belong to the plastics particles because of C2 effects. Sorry, we doesn't pay much attention here to nanoplastic because mostly is belonging to in vivo effects due to different environmental scale, sampling strategy and equipment, and analytical tools. Hopefully my talk is following strictly PICES rules and ethics. Of course, we concentrate on the Northern Pacific mostly. Goal of my talk, very simple. Rights problem with plastic of North Pacific hard to explore and resolve alone PICES member because of complexity and ocean basin scale. Awaiting results here, plastics phenomena became recognizable and understandable by PICES diaspora at least, planning the following steps for research, estimation and assessment of plastic impact to the North Pacific Ocean ecosystem and vice versa. Slide 3. It is, we see very famous ocean cleanup picture. And here we can find out at least 5 accumulation zones of plastics in the world ocean. One of them, of course, is belonging or located to the North Pacific. Probably they should to have another 6 place where plastics accumulated, but we talk about slightly later. Slide 4. If you compare a previous picture with location zone of plastics in the world ocean with total chlorophyll map from remote sensing, or old data beginning 96 up to middle of September that year, we can easily understand and can to explore what all plastic locations are in the oligotrophic zone of the ocean or near northern edge of oligotrophic zones. Here it's important for following talk. Slide 5. What we are known exactly and approximately. First of all, from production point of view, we know absolutely exactly how much plastics production is for the old industry. But less data and not so accuracy we have when we estimate plastic marine debris accumulated in the ocean. So it's very wide range. Slide 6. Is here a paradox? Yes, because plastic in the ocean should to accumulate. At the same time, plastic's mass in the ocean is unknown mostly, despite a surface density distribution for world ocean declared as equal to 6,000 particles per square kilometer. It's newest data published that year. Yes, of course, we develop an understanding of life cycle and fate of plastic in the water. Please, for introduction, link to the, for example, FUI colloquium by Morse, both colleagues from 2019, microplastic in the ocean, emergency or exaggeration. Again, just as an intro, many other sources, for example, Irina Chubarenko et al. 21, plastics in marine water, European Commission, a lot of sources, and so on and so on. Well, taking into account millions of ton plastics load annually to the ocean ecosystems, we must have an increasing, at least, plastics concentrations, but we not obtained that at all. Example, region outside Great Pacific Garbage Patch, for example, Gulf of Alaska and vicinities, proofs next to page or slide. Fortunately, slide 7, we have predecessors for plastic research in the North Pacific. It's data from middle of 80s up to 88, published by NOAA. They were lucky enough to discover a main distribution of plastic in the Northern Pacific, including Sea of Japan or East Sea, outside economical zone near Russian coast, and not discovered Great Pacific Garbage Patch, what will be discovered later after 20-25 years. But importantly, and more serious scientific result, we have not only distribution, we have here also mass determination of plastics in the ocean. Again, we have distribution and we have mass determination, for example, in subarctic water for Northern Pacific. 8th slide. Let us take a look for the picture on the map. And do not pay much attention for Great Pacific Garbage Patch. It will be next slide. Here, let us look at Gulf of Alaska and vicinities. In the table, we saw H-type as hard-type plastic, N-type as nylon-type plastic, P-type as polypropylene plastic, and F-type plastic is foam plastics. And in the right down corner of table, we saw first order tenths of mass as gram per square kilometer and first 10,000 for quantity or density per square kilometer. Our conclusion here, very simple, seems to be after 30 plus years, no increase in density and mass of plastic for the subarctic waters of the Northern Pacific, based on the same sampling juice, I mean Newton made. It's already published in 2020 by Eggers and co-authors. Slide number 9. Suppose plastics paradox is existing in the ocean. What is explanation or how and where are disappeared millions of tons of plastics? We saw result of 2,000 meter water column along Hawaii, from Hawaii to North America continent line, published by Eggers, Sulu, Gambari, and Lebreton in 2020. We saw numerical and mass concentration, and saw cloud going down to the bottom, plastics under Great Pacific Garbage Patch. Slide 10. Is here a global conveyor participate? Perhaps, but at least we can see the shape of global conveyor. It's close enough to plastic accumulation zone, at least. And by the way, the velocity or rate of movement water in deep in the ocean, not so quick, but probably enough for just loaded from surface 10 of millions ton interior of the ocean. In the Northern Atlantic, there was predicted 6 zone of plastic accumulation, but never confirmed yet. And probably the hints will be shown at the next slide. Slide 11. Let us make a short trip to the ICES area in the Northern Atlantic, where we have sediment traps results. And we saw at the end of Northern Atlantic huge amount of flow particles in the deepest layer, more than 2,000. Perhaps it is answer why Gozer and other colleagues published in 2014 and 2017 results of modeling about possibility to accumulate plastics in the Northern Atlantic have no results, because 2 huge vertical movements here going to the interior of Atlantic Ocean, and probably here began long way by conveyor belt and for plastics too. Important slide number 12. How big became small regarding plastics particles and sinking beyond conveyor impact. Conveyor impact, I mean, here is weathering and mechanical impact from currents, waves, and so on. First of all, we have colonization effect and breaking plastics. As example, see to the photo A provided by Philip Sapochnikov, Institute Archaeology имени Russian Academy of Science. Well, Plastics can sunken by adding weight of organism, including microbial colonization. Small epipelagic predators as Gasterosaurus is and as candidate of plastic-eating excretion. Same for Myctophidae, for example, Myctophidae, for example, as candidate for plastic-eating excretion. So the sense of slide 12 is shown what biota has very strong impact to the plastic in the ocean. And please do not forget about. 13th slide. If it is repeated what's rational itself, I think repeating Norway 80s research in North Pacific for comparing at new technological level and quantitative will be great results for, especially for plastics research. Because growing plastics flow to the Pacific, research in open North Pacific will provide better understanding plastics presence and fate for each PICES country in an economical zone, fishery and environmental there. Might be add probably plastics fish research over North Pacific for the commercial as well abundant species as routine monitoring tool with exchanging information about because of global phenomena. Might be add abyssal depth sediment sampling as new approach, plus sediment traps collection reanalysis with perspective of a new page of the Pacific plastics research. And because we have perspective for joint scientific efforts between PICES and ICES, diasporas of scientists. And by the way, PICES has own 42 working group which might be considering and developing idea to up to executable details. 14th slide. We saw two gentlemen, their name is Kenyon Carl and Kridil Evgeny. It's both authors provided absolutely first in scientific literature plastic phenomena in the ocean, in the birds, and they are ornithologists. Again, the research of plastic in the Pacific Ocean and World Ocean began from 1969, what should be not so, let me say, not so young phenomena and problem. So about 50 years. With history of plastic production about 100, despite what usually all scientific papers began from mark time 50, when big industry million tons began in 50. But again, the phenomena began 100 ago in 80s, and first person who provided first outlook to plastic for water ecosystem was ornithologists. For North Pacific, we also find out 1988 literature when plastic pellets was discovered in the stomachs of birds for Commander Island, North Pacific. By the way, plastic pellets not so often existing and covered by Newton net. Usual it's 1%, even less, because all of plastic pellets usually eaten by birds and fish. Slide 15. Let me a little read my own text. Plastics and the biota. Widespread contamination of microplastics may lead to internalization in fish. Literature review from March 19 to March 20 details what a median of 60% of fish belonging to 198 species captured in 24 countries contain microplastics in their organs. Carnivorous species ingested more microplastics than omnivores. Only 14% of fish were from aquaculture. Most studies focus on digestive systems. 44% marine birds ingest plastics. Sea turtles eat plastics, as well as 26 marine mammal species, with total accounting from 267 in 28 year to more than 4,000 in recent time marine bird species. With unavoidable discussion plastics impact to the water animals and vice versa, and follow-up to the humans. Here we should be more precisely raising of accent to the opposite process. How biota impact to the plastics, adding to physical and chemical factors, eliminations for plastics from biotopes and ecosystems. Slide 16. Well, have a niche for a new technology for this kind of research of, microplastics in the ocean and plastic in the ocean? Well, remote sensing from time-lapse camera through airborne imagery system up to satellite. Unfortunately, no possibility for automatic measurements aiming plastics accounting in situ. As consequence, a lot of personal handwork with sampling and analysis still remain. Autonomous platforms, Celeron, will come for the plastics observations. And of course, here still a huge window for the standard different research vessels with scientific crews. Pacific all at your boats. Please see next slide. Slide 17. Here we have absolutely good results and an example of joint efforts for a specific task. NPAF example with winter salmon. We have multi-vessel expedition with project life cycle about 5 years. By the way, some results for plastics research was shown here in my presentation. So despite all odds are and of course will be, it's real opportunity to communicate, to organize some kind of expedition in the scale of whole Pacific. Slide 18. At last, and even ocean ecosystems are efficient for utilizing plastics. Hypothesis is the quantity of accumulating plastics became enough inside whole ocean to feed up plastics each economical zone from open ocean, among other sources, atmospheric transport, fisheries, riverine input. Better to monitor plastics in the water, low trophic levels, nectar, sediments, benthos, because not enough data about how plastics density and mass are static in ecosystems with time, and especially within Northern Pacific Ocean, and how long that would be lasted. Again, looking what's happening with plastic inside each economical zone. Hard to understand without whole Northern Pacific survey. Slide 19. Frankly, why thinking about repeating of the plastics research in the North Pacific has a scientific sense? PICES Working Group number 42 and ICES Working Group about marine litter. Welcome and okay. Go ahead, please. And do not forget, plastics too interdisciplinary. So probably it's time for prioritizing. Seems to be, or should be, that phenomena should be continued, at least for research. Thank you, PICES signboard, think tank, for listening to me.
Thank you. Hi, everyone. My name is Akash Sastry. I'm the Bio Committee member to Science Board, and I'm going to introduce our next speaker, who I think is already well known to most of you. It's Stephen Bograd. He's from NOAA in Monterey, California, and some of his activities in PICES include he's the co-chair of the Future Science Steering Committee. He's also a member of multiple groups, including the AP Advisory Panel on Early Career Ocean Professionals and UN Decade of the Oceans. And that relates to his talk, I think, on SmartNet, which is at ICES PICES on those special activities. So, Stephen, please.
Okay, well, thank you, everybody. Good afternoon. So today I am going to talk about promoting PICES and IDC's leadership in the UN Decade of Ocean Science for Sustainable Development. And I'll go ahead and take my mask off so you can hear me a little better. And in particular, I'm going to talk about the SmartNet program that you've already heard probably a lot about already. And really what I want this to be is kind of an invitation to the PICES community to participate and be a part of helping us develop this program. So I'll give a couple of obligatory slides on, what is the UN Ocean Decade and how does SmartNet fit into it. Talk a little bit about what is SmartNet, its objectives and structure. What is SmartNet doing now, in particular outreach and networking. And then most importantly, how can you get involved in SmartNet? So SmartNet is only going to succeed if we have the infusion of ideas and enthusiasm from the PICES community and really all of your networks. Okay, so the UN Decade of Ocean Science for Sustainable Development is a framework that brings stakeholders together across the globe to collaborate on ocean research and management. So really it's a tool or a framework, a catalyst, if you will, for developing partnerships internationally in support of the Sustainable Development Goals. So it's really, I think we can think of it as sort of a once-in-a-career opportunity to really do some of this great international work. You've seen this already, the Ocean Decade outcomes. This is the ocean we want after a decade. So we want a safe ocean, a predicted ocean, a resilient ocean, a healthy ocean, a productive ocean, an accessible ocean, and an inspiring and engaging ocean. So we want all of these things. But of course, to get there, there's a number of challenges that have been identified that we need to get through. I won't go through all of these here, but I'm sure all of you can probably find one or two of these that relate very much to the work that you're doing as well. And then within the PICES context, I think, I'll just point out a couple of these that are particularly critical. Protect and restore ecosystems and biodiversity, and unlock ocean-based solutions to climate change. So this really fits into the PICES experience and expertise, although all of these challenges are going to be important to address as SmartNet moves forward. So again, you've seen this also, the framework of the Ocean Decade, how we go from the ocean we have through those challenges to the ocean we want, and how we do the science we need within there. And it's the decade actions that is really the currency of the ocean decade. This is how the science is going to get done. And there's several levels of actions, from contributions, which might be like a financial contribution from a NGO or an entrepreneur or a national government, to one-time activities, for example, symposia. So the Small Pelagic Fish Symposium that's coming up that PICES is sponsoring is a decade-endorsed activity, for example. And then broader levels are projects, and then up to programs. And the programs are really the ones that are meant to be really cross-disciplinary, multinational, more global in scale. So the IOC gets proposals for these different actions and vets them to make sure that they're in line with the Ocean Decade objectives. So what are the benefits of participating in the Ocean Decade? Well, there's a lot of them. It brings formal recognition to endorsed decade actions. It amplifies the work and makes it attractive to funders, hopefully. Serves as an umbrella for and strengthens international and multi-stakeholder collaboration. It leverages global and regional networks and communication channels. It supports co-design and elevates voices of community members, especially, hopefully, the underrepresented communities, and helps to address global challenges and create solutions in the face of rapid change. So this is, again, like I said, a once-in-a-career opportunity that we really want to take advantage of. So what is SmartNet? So you've seen this earlier. SmartNet stands for Sustainability of Marine Ecosystems through Global Knowledge Networks. And so this is the program that is sponsored by PICES and our sister organization in the North Atlantic, ICES. It's interesting to think about the origin of this program. We first started thinking about this the last time we were all together in October 2019 at the PICES annual meeting in Victoria. There were some ICES folks there, and a few of us got together and said, hey, ICES and PICES are really the leading marine intergovernmental organizations in the Northern Hemisphere. This decade is starting. We need to be proactive and take on a leadership role in the decade, and that's what we aim to do. So over the next several months, we developed this SmartNet proposal, submitted it in the first round of call for actions, and we were endorsed last summer in the first round of endorsements as a notion, what they call decade or networking program. So as part of our networking responsibilities, there's very particular cross-cutting themes that we really want to invest our time and energy into. And just going through these quickly, science communication, doing great science is fine, but unless you can communicate it to the right stakeholders, it's not going to be useful. Promotion of early career ocean professionals is critically important. They're the ones who are going to inherit that beautiful ocean after 10 years. There we go. Incorporation of indigenous knowledge is very critical, and we'll hear more about that later this afternoon. Empowerment of women, involvement of SIDS, we heard about that this morning from Naya as well, and greener ocean science. So we want to really make strides and progress in all of these aspects. And overall, the ambition of SmartNet is to really leverage and build on the existing joint activities of our two organizations. So we've been working together for decades. We have this fabulous infrastructure in both organizations, and we really want to build upon that to facilitate research and knowledge generation for our members and beyond, to share research, develop ideas, and contribute to sustainable ocean solutions. And I'll just point out that beyond part, because the Ocean Decade is meant to be transformative, and so it's not business as usual. And so really what we're trying to do within SmartNet is to really amplify the impact of PICES science and PICES activities, and ICES too, beyond our normal convention areas of the North Pacific or North Atlantic, into the global south, for example. So we're in the very early stages, phase 1 of SmartNet. We have this iPod steering committee. Myself and Sanai Chiba from the Secretariat are chairs from PICES, and then we have Lisa Paramaki and Jorn Schmidt from ICES. Our initial strategy or priorities are to draft a strategy that prioritizes engagement with ECOPs, indigenous communities, developing nations, and recognizes the importance of promoting diversity and gender equity in all of our activities. A really critical thing that we're doing at this early stage is identifying and engaging partner organizations, and we want to do that early. We don't want to build a science program and a plan and say, hey, come join us. We want them to be part of the co-design of that program. And then within our organizations, we're developing recommendations for new and existing expert groups to implement and maintain the program activities, and encourage and support expert group participation in all aspects of the decade. So you've seen this slide before. This is the future SEAS schematic, as we call it, and we can think about where does SmartNet fit into this PICES ecosystem. So the purpose of putting this schematic together was to think about how these disciplines within our PICES work and activities fit together, from the climate system to ocean processes, marine ecosystem, human system, what those connections are, and as you see there, where we can map our actual activities, like, for example, working group activities, into that schematic, into that SEAS approach. And this allows us to really identify where we have synergies and can facilitate cross-pollination, but also where the organization might have gaps that we need to fill. And then around the gray box at the end are these advisory panels. So we have the advisory panel on ECOP, advisory panel on science communication, both relatively new. And where SmartNet and Ocean Decade work within the PICES will fit is under this advisory panel on UNDOS. So we intend to provide advice on PICES engagement in the Ocean Decade. And if we think about those advisory panels, those sort of cross-cutting programs within that future schematic, what's really essential for success of SmartNet is to have a lot of synergies here between these groups in particular. Future, the flagship science program, but also involvement of ECOPS, involvement of science communication with our Ocean Decade activities. And so, we envision SmartNet as being a catalyst to facilitate some of these group collaborations. In terms of our themes, well, it's the usual PICES themes within SmartNet of climate variability and change, fisheries and ecosystem-based management, social, ecological, environmental systems dynamics, coastal communities and human dimensions. And there's a number of existing ICES-PICES joint expert groups. And so this is just a sampling of some of the ones that are in existence already. And these are the types of activities that SmartNet wants to leverage and really build from. And then, as mentioned before, the cross-cutting topics are international capacity development and enhancement, early career ocean professional development, gender awareness, diversity, equity, inclusion, and engagement with indigenous communities. So again, these are our aspirations within our program, and we're just trying to build some of these frameworks to make progress in here, as well as partnering with the wider community. And I list a few partner organizations there: Asia Pacific Network, Ocean Network Canada, Ocean Can, et cetera. So we think about the, kind of summarizing what the SmartNet program, kind of structural landscape and strategy is. So first and foremost, knowledge production. So that's ICES and PICES science. And then importantly, knowledge sharing. Both data sharing and integration, but also generation and distribution of knowledge. So we're aiming to establish a strategy for joint research and data sharing. The networking is a key part of what we're doing, of course, and that's with other Ocean Decade programs, as well as with our partner organizations, right? So we're developing a mechanism of network governance within the program. And then finally, engagement. So empowerment of diverse communities, local and traditional knowledge. And this is, here we're trying to identify and strengthen relationships with partners in that case. And also promote capacity development. Ultimately, where do we want to go? We really want to help, generate knowledge, but make sure that that knowledge is actually used for societal benefit. Okay, so SmartNet activities, as I mentioned, we're at the very early stages of our program. We're still kind of in the identifying partners. But one thing that has started are these national surveys, okay? And this is a plan for a global survey on general public perceptions about the 7 outcomes of the ocean decade. So this is similar to what Naya presented this morning from the SIDS. And again, this is coming from Mikino-san and partners both at PICES and ICES. This was initiated by the original study group on Ocean Decade and now the advisory panel on Ocean Decade. And the motivation is like, you know, the theme of the decade, the ocean we want. As Naya mentioned, who's we, right? And if you ask different people, different communities that question, you might get very different answers. But we need to do that so that we know how to accomplish the goals of the decade and make sure that a diverse set of stakeholders are happy with the ocean that we get to. And so they've got a little bit of funding to do a pilot study that's going to begin in January in France, US, and Japan, where again, they're going to do these surveys for the general public in those 3 countries. And the aim of it will help us discuss and identify the direction of ICES and PICES international science collaboration within SmartNet and beyond. And also help us make recommendations for science policy, national, regional, international. And the idea is to repeat that global survey in 2026, so halfway through the ocean decade, see what opinions have changed or not. And then in 2031, after ocean decade is completed, to get an assessment of what the ocean decade impacts to the world are. And so this will give folks like Mikino-san, Naya et al. This general theory of the ocean and humans, and allow us to look at commonalities and differences across ecological factors, different geographical regions, ecosystem types, biological productivities, biodiversity regimes, et cetera, as well as social factors, political, religious groups, histories, education levels, et cetera. Another activity, again, outreach and networking is what we're doing at the very outset here. And one of the first efforts we had on this was to do a satellite event at the Ocean Decade Laboratory on a productive ocean, which was held this past summer. And so essentially this was a virtual seminar to introduce SmartNet to the global community, the Decade community, and begin to provide some networking opportunities with potential partners and stakeholders, and try to advance progress around the key themes of the program. And so we had really good turnout. We had over 50 people. We had a great set of panelists and speakers, and a really good initial discussion, and began doing some networking with international organizations. SmartNet workshops, this is another way that we're trying to provide outreach and networking and get the word out about the program. So we actually had a workshop, was it yesterday? Yeah, it was yesterday, right here in Busan. And it was really well attended. There were a number of ECOPs there as well. We had discussions from, I think, 5 different Ocean Decade programs that have some sort of PICES relationship. So that was a really exciting event. It's done. We have another workshop planned for the effects of climate change on the world ocean program in April in Norway next year. And here we're really trying to bring Ocean Decade programs together to think about how do we co-design activities and collaborate in the most effective and optimal way, especially around that climate fisheries nexus. And then we hope to have another workshop on SmartNet a year from now at the PICES annual meeting in Seattle in 2023. And that's going to be more on less introducing what is SmartNet, but more like really starting to develop some ideas for sharing capacity and promoting solutions for marine ecosystem sustainability within the decade. And so this is where we really want to make sure we invite the right stakeholders and folks to participate in that event. And we would love to have another 1 or 2 ECOPs as co-conveners. We have 1 ECOP co-convener, Hannah LaChance, for that one, but we would love to have others as well. Okay, so how do you get involved in SmartNet? Well, first, just you can learn more about the Ocean Decade, go to their website there, and they have this global stakeholder forum, which is in some ways kind of like a Facebook for the decade of the marine science community, which you can join and get updates on what's going on. A couple of times a year, the IOC launches these Call for Decade Actions. They just wrapped one up recently, but there'll be another one early in 2023. And so this is where you can propose activities. And again, it could be just a simple, a single activity such as a symposium, all the way up to projects and programs. So I encourage you to look into the options for that. Manu mentioned the Decade Collaborative Centers, which are aiming to really help the decade succeed. And there's several Decade Collaborative Centers around the world focused on particular themes, like the Climate Ocean Nexus with the Georgia or Ocean Visions DCC. But we're really lucky within PICES that we have an Ocean Decade Collaborative Center for the Northeast Pacific, and that's run out of the Tula Foundation in British Columbia. And what it aims to do is to help us coordinate across programs and projects, catalyze new decade actions, facilitate knowledge co-production and stakeholder engagement, amplify our decade actions to build public awareness, get the word out, and monitor and evaluate these decade actions. And that's led by Rebecca Martone at the Tula Foundation, and she has a wonderful and diverse team of folks who can help us work on that. Okay, so back to the PICES ecosystem. Where does SmartNet fit in, and how do you get involved? And one point that, a take-home message from this presentation, I hope, is that really all of the work that you guys are doing within PICES in your expert groups, your committees, your working groups, et cetera, I think could be part of the SmartNet program. It really is relevant to what we're trying to do. And what you should think of SmartNet is as a way to sort of amplify and promote and bring that science to collaborators and networks, both within and outside of the PICES community. And just to give one really nice example, I think, is, and you heard a little bit about this morning as well, is this PICES special project called Sequiterra, funded by Japan's Ministry of Agriculture, Forestry and Fisheries. And so this is run through the section on human dimensions. And so the aim here is to build local warning networks for the detection and human dimensions of Sequiterra fish poisoning in Indonesian communities. Okay, so this is not a SmartNet action per se, but it's a beautiful template, I think, of the kind of work that SmartNet can be doing and will be doing in the future, and that PICES could be doing as part of the Ocean Decade, because it involves all these elements that are so critical for the success of the decade. Co-designing the science with local communities, involvement of that local community in actual data collection, dissemination, and use, sharing and developing capacity, and it's very solution-focused. It dealt with a particular problem that was identified by those local communities in Indonesia. So that, to me, is a really beautiful example, I think. So how do you get involved? Try to integrate your PICES activities within SmartNet. I think we can help you amplify your work. Propose new working groups or other expert groups to help push the program forward. Participate and contribute to SmartNet workshops and other events. Facilitate outreach to your networks, both within and outside of PICES, and in particular, ECOPs, indigenous communities, non-convention countries, SIDS, and LDCs. And think about ideas for potential decade endorsement of projects and activities that could fit under the SmartNet umbrella. And please do come talk to myself or Sonai if you have any thoughts or ideas or questions about any of this. We would love to talk to you about that. As I wrap up here, I just want to let you hear a little bit about SmartNet from some PICES scientists, and this is getting back to that synergy that I talked about between these new advisory panels and the Future Science Program. So we have representatives here from the Future Scientific Steering Committee, the Secretariat, ECOPs. We have a couple of ECOPs here, one LCOP myself. And if you, and what I'm going to show you briefly here to end is a short, and I mean short, 49 seconds, video. And this was put together day before yesterday. Elliot Hazen helped produce this for us. And it was done at the workshop held by the advisory panel on science communications that Vera organized, and which was a wonderful thing. And literally in a couple of hours, we put together this this video that I'll show you in a minute. It's not going to win an Oscar, but I think it exemplifies, how we can work together and how important having ECOP engagement is, how important having good science communication is. So let's see that.
Our world's oceans are connected. Since the beginning of the time, our oceans have been essential to the well-being of the planet
and for human societies to thrive. However, our research and technology is not being shared at a pace to solve the ocean's biggest problems in this era of climate change.
A new Ocean Decade program called SmartNet brings global communities together to share research, information, and technology to solve our shared problems.
Our oceans are connected, and our science needs to be as well.
Smart people.
Smart solutions.
SmartNet.
Okay, so I hope that convinces you to join our program and help build SmartNet from the ground up and help us get to the ocean we want. All right, thank you.
Okay, thank you, Stephen. Are there any questions for Stephen? Well, I have a question then. So are you anticipating having people liaise with some of the expert groups to encourage from AP Undos or otherwise? Yeah.
So you asked about encouraging people to engage in the expert groups and help build SmartNet through the expert groups.
Right.
Yeah, no, that's very much true. I think a lot of our committees, our expert groups are already thinking in this Ocean Decade space. And thinking about, what can their committee or expert group do to support not just SmartNet, but the Ocean Decade in general. But we're also hoping to develop new working groups, new study groups that will help advance the science. So we have this new working group on climate extremes that we think is going to be, a nice contributor to some of the science that SmartNet can do.
Any questions? Anyone? No? Okay. Thank you. Okay, and our next speaker is also well known to people in PICES here, is Slava Lobanov. And Slava is from the Pacific Oceanological Institute in Vladivostok, Russia. And he's involved as well in many of these PICES expert groups. He's a member of the Future SSC as well, and also co-chair of AP CREAMS. So please welcome Slava.
Good afternoon. This is very nice beach located in the southeastern Kamchatka with three big volcanoes on background with a black sand that is open to the ocean. And there are big waves, not now, but usually there are big waves. That's why people who like surfing in the cold water from all Russia, they're on that beach. But what happened exactly 2 years ago? There was a very abrupt and massive mortality event in this beach. You see these satellite images of the Kamchatka Peninsula. Probably you know where Kamchatka is located. It's a northeastern part of Russia. close to Chukotka, maybe not far from Alaska. And there is a people said there's 95% of benthic organisms were abruptly thrown out to the beach, and they're mostly shellfishes, sea urchins, some small octopuses. That was first time in Kamchatka observed. The people say it could be happened because Kamchatka is not very, not too many people live there, so there are some places where nobody lives, so it may be happened. But first time it was registered, it was a big problem because it's surf people. There is you see this like a beer tide or kind of foam, which also visible from satellite. You see these two satellite images, one for September 15, they're like regular surf, and September 20 already very wide strip of the white foam, white yellow foam. This for that people who enjoy this for last maybe 5 years, they enjoy surfing in this area. They were the first time, and there was a big roam in Russia that people said this kind of leakage of some poisonous materials from military garbages or something like this. And there is the governor of Kamchatka. He's quite young person and very active, enthusiastic. And these surf people and divers claim that there is some kind of very bad smell, and they have some problem with stomach and some problem with eyes, and they people not very much knowledgeable about these red tides and harmful algae blooms. They start thinking this kind of some leakages from some poisonous materials from the military base or from these how to say burning polygons. So he had to find this coastal ocean solution, and there is a good example. That person start thinking he understand why do we need the ocean science, and he didn't call the regular emergency group, because the regular emergency like Ecological Service, Administration of Hydromet, they worked already there, but he called scientists. He called Russian Academy of Sciences and asked, please come to our place and try to find what is it, what is a scientific solution to how to manage with this problem, what is it. And my colleagues from Institute of Marine Biology, Forest and Federal University, and our institute, they came, and what they found, they took samples, and they found all southeastern Kamchatka area, which is about 500 kilometers area. This is a poisonous species like microalgae, Karenia. They found here, and on this diagram you may see that's not only in Avachinsky Bay. Avachinsky Bay is in the northeastern part of this slide, but also in the southern tip of Kamchatka, northern Kuril Islands, there are lots of these microalgae. So after that, this governor of Kamchatka called to the ministries and asked them to establish, to launch a new program. And actually this program was launched because of this incident, which is quite good thing for scientists. And the program called Ecological Safety of Kamchatka, the study and monitoring of natural hazards and anthropogenic impact. And this program not only for understand the reason of this particular incident, but this program was to evaluate other risks, other possible hazards or possible negative incidents in Kamchatka area. This program is quite big, and I just show you briefly what is it. This development on methods, development on satellite algorithm to identify the species, improvement on technology of satellite monitoring, and study and monitoring of abiotic environmental factors, what we are doing. So my institute is responsible for number 3. And there are also many things with microbiology, with toxicology, even there's medical things like biomedical assessment and so on. Quite a big program was started just because of enthusiasm of one person who believed that they need science, especially in such remote area like Kamchatka. And we start thinking, okay, we said, okay, we will participate, and we start thinking what could be a reason, not only for this particular things, but other risks for Kamchatka. First is global processes like global warming. It could initiate this development, the development of this algae and in high concentration and algae bloom. Other global process may be eutrophication, which is common for the ocean and maybe common in Kamchatka, but we don't know because we don't have good observations there. From mesoscale processes, there could be upwelling, and there is a East Kamchatka current which flow from north to the south along the Kamchatka coast, and you know there is a trench there, and there is very sharp slopes, and there is eddies formed in the base, and this eddies detached, they live their own life, and they're very strong dynamic features. With eddies also could form the upwelling event, which upwelling brings water up and brings nutrients to the euphotic layer. And also another important thing, there is a low oxygen water located below 200 meters, and the so-called the Pacific Intermediate water. And if upward motion may bring this low oxygen water and with high concentration of nutrients to the shelf, and also maybe a trigger mechanism for the bloom of plankton. And also from the local things, local processes, maybe submarine groundwater discharge, because Kamchatka is a kind of very seismic area. There are many volcanoes and active volcanoes. There also important the gas fluxes there. So we try to look to these processes, but not everything. This study is incomplete, so I just report about the beginning of some. So this is a daily chlorophyll maps of that period from received from satellites from September till beginning of September till the middle of October, and the incident happened in the end of September. You see on these pictures there's increase of the chlorophyll content in this area. And the question is, if, of course, probably usually this is a seasonal phenomena, but this diagram in the right part of the figures, they show the difference between 2020. It was special year. In blue color is the average seasonal average variation of the chlorophyll for that area, but red line is for particular 2020. You see a very sharp increase. This is monthly average values. A sharp increase in September, October, and so on. But in compare next year, 2021, there is not like this. It's more closer to regular things. So why this year was special? There is also another satellite data which shows this transport of this. You see in orange and red color, this is a high chlorophyll concentration, which is associated with the Karenia. And we can see how it moves southward along the coast of Kamchatka. Then we look to interannual variability of air temperature and sea surface temperature. On the left, there is data from meteorological station, and we can see the trend for air temperatures increasing last 40 years, of course, and water temperature also, and the rate of increase is higher than average in the world ocean. And also reanalysis gives us the same. But what we can see is summer processes is more stronger. So we have more higher increase in summer than in winter. And then we look particular to the this base. These graphs demonstrate variation of temperature for last 40 years for Avachinski Bay, which is where incident was observed, and next to the North Kranotski Bay, you can see this. Even both bays has a quite big, quite large, strong positive trend, but Avachinski Bay even stronger. So this is like a special place where this warming was observed. And this is a daily SST retrieved from satellite data. You can see this, we observed the blue, light blue is average for how many, 40 years approximately, and red line for particular 2020. It was kind of special year, so those, we have some peaks of abrupt increasing of temperature. Why this was happening, we do not know. We need to look more closer. And then important thing is mesoscale eddies. So mesoscale eddies, they very strong dynamic features, especially along Kamchatka, as I mentioned. This figure shows some example of this eddies. They travel along the Kamchatka, and when they come close to the coast, they may produce upward motion of the water, so-called upwelling event. But also, eddies trap water and they transport. For example, they could take a cyst of this microalgae in the northern area, where our biologists said there are more concentration in the northern Kamchatka, and they may transport them to the south. And this is an example of how this eddy travel. This is the calculation, Lagrangian calculation from the altimetric data. You see they move. And the eddy right side in the bottom, there is a section of the eddy. You see this could be upwelling in the periphery of the eddies, edge of the eddies, upward motion of the water. But this is a section of dissolved oxygen, and Kamchatka is on the right side. You see there is water with very low oxygen, located only at the depth 200, 100 meters. So there is enough, some upward motion, as this water may be on the shelf. And they may induce the same case of mortality just because of very low oxygen. Plus, this water contains nutrients, and as a result, there may be very strong plankton bloom. So again, looking for the, we looked for this particular period for when this incident mortality happened, but it's difficult to find because there are some figures taken from calculation from altimetry, Lagrangian simulation, but there's eddies, they're very fast moving, it's very not stable, so difficult to judge if they were result of the eddy upwelling or not. So we made in 2020, when our ship came back from the Arctic Ocean, we asked them to do some observations in that area, and you see a section across the eddy, and you see the very low dissolved oxygen content on the periphery, but unfortunately not at the coastal area, but opposite. But eddy rotation, we may expect that its low oxygen may be close to the coast, but at the moment we have not found this. And this is another example of eddy in section in Avachinski Bay. And so this summer we had observation in that area, and we tried to look to the structure of the eddy, but again, the eddy already left the Avachinski Bay, so we were a little bit late. But what we found, and this is a satellite images, temperature and chlorophyll. You see that inside the eddies there's a water with a cold and with a high content of chlorophyll. But what is important on the periphery of the eddy, on the eddy edge, there were very high content of chlorophyll concentration. And here we look at the distribution of temperature and salinity. And you see that important thing, that eddy traps the water from the coast. The very low, what was surprising to us, this open ocean, but very low salinity close to the shore in Avachinski Bay. There are no big rivers in Kamchatka. Why this salinity is very low? And you see the eddy, because anticyclonic, it takes water from the coast and they transport water to open ocean, and then for very far distance. And this water contains very high concentration of nutrients, at least silica, and this is a good background for development of plankton. What is such low salinity? There is the photograph of Kamchatka coast. You see, it was the beginning of July, but this is a season of snow melting, and there are many such small canyons, and the snow comes down, and this canyon ends with a small waterfall or spring, and it supplies lots of fresh water to the ocean. Even you see the water is green color, but this is open ocean, just maybe 50 miles toward the open ocean, the water different color. It was very surprising, so very strong. And we need to study the biogeochemical properties of this water next time. Okay, so I will not conclude because I have no conclusion because this is not concluded work, but our future work we like to look at the long-term variability of chemical parameters. We do not have good observation in this area, but we have water cruises and we have our joint project with Jumpstick on Mirai cruises maybe 20 years ago and 30 years ago. Probably next year we will do accurate chemical measurement to compare what's happening here, especially vertical structure of nutrients and dissolved oxygen and other chemical parameters. And we like to look at short-term variability, and we deployed 2 moorings close to this bay where it happened. And maybe in November we will try to recover the moorings and look, because nobody measured this moorings there. And possibility of pools eutrophication by rivers, because this is also an important phenomenon when there is a very strong heavy rains or this fast melting of ice, there will be pool eutrophication. Submarine groundwater discharge and methane fluxes from the bottom are also very important phenomenon. Okay, so that's all from me, and I just mentioned the example of the person who knows why do we need marine sciences stimulated this quite interesting program. Thank you.
Thank you for your nice presentation. You were talking about abiotic factors, but I would like to ask you to think about biotic factors if it is possible. Maybe or maybe not, Karenia species may have be associated with microbiota communities, which could be harmful, like pathogenic bacteria or viruses. That kind of microbiome and very difficult to do may be helpful sometimes, I think.
Yes, thank you. Thank you for your question, but I'm not a biologist, but what we're doing is abiotic factors, but I may ask my biological colleagues when I come back home and then about this.
Yeah, thank you, Slava. It's a very interesting story, and it seems like there was a lot of suspicion and sort of wild stories that were coming out, and then the scientists really put a picture together. I know it's not complete yet, but was there any outreach to the communities after the fact, after some of the science was done, to say, hey, look, this is why we need marine science, and this is how we can put this picture together?
Yeah, yes, of course, because this Kamchatka Peninsula, there's only 300,000 people living there, and the people, they would like, they like marine science because they have fishery, navy, and again, some sailors, seamen. So I was on Kamchatka in July and talked with local people. They would like to feel themselves knowledgeable in marine sciences, but the problem is there are not many, there are 2 small universities there, and now because of this program there is decision to organize a center for, how to say, ecological monitoring, and they ask us from Russian Academy of Sciences participate in this center to like increase level of education on Kamchatka. So the answer is yes, people would like to be familiar with the scientific issues.
Hey, Slava, over here. Thanks for the leading us through that detective story. We're kind of on the edge of our seats here. You mentioned seeing this event. Are there any local sources of knowledge about whether this happened before?
Yeah, there could be this, but because this area was not studied, even there is a fisheries institute, you know, probably Kamchat-Nero, but they do studies very in the Avachinsky Bay, the inner bay, and very coastal areas. So not many research on this, but it is actually very interesting because what we did now, but I do not have a result with our chemical groups. We just took samples from the rivers, and we took samples of snow, so many different samples to look at the local, some possible local inputs. Because there are volcanoes, some volcanoes are active, so it's a very dynamic place.
Thank you for nice talk. So my name is Atsushi Yamaguchi from Hokkaido University. And I want to just inform you the similar Karenia seriformis harmful algal bloom was also occurred for the east coast of the Hokkaido island. The 2021 is September to October is very mass mortality of salmon and sea urchin. And we are considering the marine heat wave before the autumn, such as July and August. It's a very high temperature was the cases for the east coast of the Hokkaido island. It's similar to the east coast of the Kamchatka Islands. And how about the 2021, 2022? Are there any harmful algal bloom by the Karenia is occurred for the east coast of Kamchatka?
No. Yes, I know about this case in Hokkaido in 2021, and even we tried to trace the motion using this Lagrangian approach. We try to trace the motion of water particles. If it could be possible from the Kamchatka to Hokkaido, and it could be possible. But probably you are right. This warming is one of the important reasons. But as I mentioned, this on Kamchatka 2020, September 2020 was extremely warm. 2021 was not so warm, and this year 22 also not so warm. That's why there were no, the correlation between temperature and chlorophyll is very high. I didn't show these slides, but they're very high correlation. So probably warming is one of the reasons. But as I mentioned, for us, so governor of Kamchatka, he would like to know other risks, not only this like HAB, but maybe other problems with negative application to the social things or ecology. That's why we explore another mechanism.
Thank you very much. I'm Arif from Indonesia. One thing that you can look when there's a blooms of harmful algae happen, especially for Karenia species, you can look at the cyst that could be deposited into the sediment to look at have they been there for a long time before, but something disrupt the sediment and then it's suspended to the water and then they bloom, or maybe they're coming from somewhere. So after this, they also will produce cysts that will deposit, and then the same case will happen again sometimes in the future. That is something that we need to look at, because it's a similar case happened in Indonesia, but with the different species. New species suddenly blooms and they stop blooming after that, and it never happened before, and then it coming up after 10 or 20 years. Thank you.
Yeah, thank you very much. That's what our specialist on HAB, like Tatiana Orlova, She said this northern Kamchatka is there are many seas of this Karenia may be located. But again, there are not many observations, not many studies in that area. And we're going to do more observations to understand this. Okay, probably not polite to spend.
Well, that's okay. I think we're going into a coffee break anyway. And so you can take advantage of Slava's time, their coffee break, and ask them questions there as well. Okay, thank you, everyone.
And please be back at 4:30. Thank you.
Okay, welcome back everybody. People can come in and take a seat. We're going to start with the next couple of talks. So I'm happy to present the next speaker, Dr. Jack Barr, from Oregon State University in the U.S., a long-time member and contributor to the PICES community, a member of Governing Council of the U.S., as well as AP and PICES and the Monitoring Committee. Jack.
All right, good afternoon, everyone. Thanks for hanging in there. So I have one very important announcement before I start. That is, if you saw in the pictures in the tribute to Hal Batchelor, several of us were on the PICES swim team. So, Wednesday morning, 7 a.m., in front of the Paradise, we're going to do a PICES swim. And invite all of you. This is going to be the easiest one we've ever done. There's no half-hour drive. There's no getting up in Vladivostok in the dark and swimming in the cold water. So please join us. And I can't see any of you. All right, so I'm going to do another bit of a detective story like Slava did. And we're going to make use of this incredible amount of data that was collected in 2021. In the Northeast Pacific. And I'm coming at this a bit the point of view that Slava had. We need the science to inform sustainable use of the ocean. So that's where we're headed. Bunch of co-authors, they're listed there. Several are in the audience. This is a collaborative effort to pool our data to understand one of the stressors in our coastal ocean off Oregon and Washington. So again, I'll just remind us overall goal is to sustainably live with our ocean and our coasts. We've got sustainable fisheries, but we do have some pressures on those areas. You can see the offshore wind buoys at the very bottom of Chicken is a waving buoy. In the lower left are very large ocean observatories, buoys, so the research community is making use of space in the coastal ocean. We've got spirituality and recreation, and then you'll see in the right the conflict between migrating whales and crab pots, where habitat is squeezed. So where I'm coming from is we need to know as much as we can about that habitat in that area as we make decisions. So quick introduction to the Northwest Pacific. We're in the upwelling zone of the Northern California Current. Just to the south is where the North Pacific splits and goes into the top of the California Current. On the right is a satellite image showing the cold water upwell along the coast in the summer. And we're going to be looking at the northern end of that. So wind-driven upwelling, it's seasonal at this latitude. Just got a rendition of the seasonal cycle. And I'll be talking about upwelling between the spring transition and the fall transition. And the little cartoon in the bottom just shows how currents are bringing upwelled waters up, the strong coastal jet flowing down along the coast. This is an incredibly productive area as the upwelled waters come up with nutrients, hits the light zone. We get great plankton blooms and high productivity all along the coast into our estuaries, etc. And superimposed on this is some of the ocean observing assets that we're lucky to have off the Pacific Northwest, funded by our NOAA Integrated Ocean System. And in the spirit of data sharing, you can go to some of these sites, buoys, gliders, and pull that data off, investigate the questions like we do together. Very successful fishery in Oregon alone. Our Dungeness crab fishery, about 74 million a year, groundfish, pink strip and then the iconic salmon. So we want to understand this area, we want to understand the kind of stress. And one in particular is the low oxygen. So this is a diagram we did many years ago just to summarize the process. So deeper in the water column, the water has been isolated from the atmosphere. It's traveled in some cases for decades to reach our shore. And then that process pulls that old water into the euphotic zone. So it's low in oxygen to begin with. It comes up on the shelf, sugars, plankton, and then that organic matter falls to the bottom and decays. And it's that combination of the source water properties and what's happening on the shelf that actually drives the water hypoxic. And this naturally occurs. In fact, many organisms are adapted to it out on the outer shelf on the slope. But I think what's new is we're seeing it very close to shore, and we're seeing it more frequently and more longer duration. So that's a photograph of our small research vessel. This is a kilometer or so offshore. And you can see the crabbing boat behind me working just to the shore of us. So we're looking at that very inner edge of what is a hypoxic. And just as an aside, that oxygen minimum zone is actually quite deep at our latitude. It's maximum around 600 meters, but at the very top of it, 150 to 200 meters, we're pulling water off the very top of it up onto our shelf. And it's also high CO2, low pH. So that's another stressor we'll be looking at as we go along. All right, what are hypoxic zones? Normally they're associated with river plume runoff in many of our nations where there's excess nutrients, drives plankton blooms, the decay process pulls the oxygen out of the water. Even more true for salmon enclosed areas like in the photograph on the left. But we're actually seeing an open ocean coastal context. The middle photograph is a ROV from the seafloor off Oregon in 2006. We saw massive die-offs, including the invertebrates from the seafloor itself. Sort of reminiscent of what Slava showed was actually on the beach. This is a photograph on the right on the Washington coast showing the effects of the hypoxic zone. So I'm going to use mixed units. I'm going to use actually milliliters per liter. So when that number gets less than 1.4, which is equivalent to about 60 micromoles per kilogram. And those are the different ways that we talk about oxygen levels at the bottom there. All right, so we want to measure that at sea. So stick with me here a second. We have all these great satellites. We can see the plankton, we can see the temperatures, we can see something about the waves, and from that infer the wind. But there really is no way to see down into the ocean to measure the oxygen. So we've got to put something in the sensor. Traditionally, we do it with ships. We can lower down the sensors. We can capture water. We can use the latest technology if we wish. The set of photographs on the right-hand side is from one of the first summer schools in ocean observing. And some of you that are now, I guess, early/mid-career folks now might see yourself in those pictures. The upper plot is a CTD inside a strong TTC tube that goes onto a trawl. This is done by the NOAA groundfish survey, which I'll show you some data from. The lower one is just one of our training exercises on our small research vessels where the students are learning how to take a sample to get it ready for a wing titration. In the middle is what many of us have been doing for a decade plus now, and that's using an autonomous glider equipped with CTD, dissolved oxygen, to go from the sea surface to right down to within about 3 meters of the bottom to sample the oxygen. All right, so I was just out September 1st, 16th on a mission off the Washington coast. Actually, my job has gotten a little easier. I only have to go on the first day, put it in, and then I go home and we run it from our cell phone. And then we go out on the last day and pick it up. There's the little zigzag pattern along the coast, and on the NANI's website, we plotted out the oxygen from the sea surface near the seafloor. So with the way color palettes work, red is good, blue is bad. So that blue water near the seafloor is low oxygen water. And you can see it makes its way all the way to about 25 meters in space. And each one of those color profiles is a dive or line from the glider. Okay, so when we went out on the 16th, we picked up the glider, and I brought it up to the Native American group in Tahoe, Washington. This is the Quinault Indian Nation. So we've been talking today and yesterday about bringing in more local knowledge and indigenous observations. So we took the glider to the Quinault Tahoe school, and I first thought I was going to have a bunch of 8th through 12th graders, and I could really spend some time taking the glider apart and putting it back together. But the principal said, you're driving all this way, let's have the whole school. So it was K through 12, from little tiny guys who wanted to know why we needed yellow, to the high schoolers that were asking very sophisticated questions about what are we going to do with the data, or what careers are there in marine science. So great experience. I'd like to propose doing a longer workshop. And I have no idea what to do with my arms. Okay, so there has been previous work done on this. Some of the authors are in the audience. If you take some of the NOAA data from the various surveys and plot out the nearby oxygen, and again, that same palette from blue, which is bad, and up to red, which is saturated with oxygen. And you make a map along the coast. And what you see is changing patterns north to south, there's an on and offshore gradient. And sometimes there's quite large areas where it's toxic. For example, September 2011, up on the Washington shelf. They had about 40 to 60 stations to work with in those days. All right, so what we decided to do is gather all the data we could find. 2021 was an absolutely remarkable year for vessels at sea and gliders at sea. You can see some of the NOAA's listed there. The Juvenile Salmon Cruise, the Northern California Current Study, the annual or biennial hake and groundfish surveys, Dick Feely's, who leads the West Coast Ocean Acidification Survey, and out to the International Pacific Halibut Commission, sends out oceanographic vessels. And then our Oregon Department of Fish and Wildlife was looking at state lakes, which is about 5 miles offshore. And then in blue are things I've been running offshore the gliders, and you can see some of that mapping in the bright blue off the Washington coast that I just gave you a taste of. So there were something like 800 profiles all the way down to near the seafloor. So we're going to collect that data and map it. So it's kind of like bringing a set of glasses to look at this in really sharp focus. So we're going to put that together. And this is how that data was distributed in time. So I mentioned spring transition and fall transition. So right around mid-March, out into September, when the winds turn around again and stop. And those are each of the types of surveys spread around time. Interestingly, they are weighted a little bit towards the later in the season. And part of the story is that the oxygen does decline in the season, such that the months of July, August, and September is the worst. And Francis Tran and I have been trying to communicate about what this is. And we latched onto this idea that in the Pacific Northwest there was a smoke you see from the fire late in the summer. And we can all see that there's smoke in the air. Everybody knows that. But nobody knows what the ocean is like. So we've started to use this term hypoxia season to give that visual of the fire season, the smoke season. And I think that's starting to get to people. Late in the summer, there is this stress. All right, 2021 was also a remarkable year for upwelling. So lots of it persisted, and that just fuels that engine I was telling you about that produces organic material that can then be decayed on the shelf. And this diagram on the right just adds up all the upwelling over time in the season. And the blue line is 2021, and the further down it goes, the more upwelling. And it's roughly twice the average upwelling. So we might expect this to be a rather hypoxic year. All right, so here's the map. We take all the near bottom data, we put it into a spline fit routine that actually makes an inquiry of the nearby data and checks for significance. The length scales of the smoothing change depending on how the data is distributed. So there's some quite short scale phenomena, especially up there in the north where we have the glider data. So one quick calculation is you can just simply add up inshore of 200 meters how much was hypoxic. This is the average for the upwelling season, and over 70% of the shelf was hypoxic. That's remarkable. All right, well, let's look at some of the features. There's low dissolved oxygen in a few patches. So up there in the north on the Washington Shelf, there's a noticeable patch off the Columbia River in the middle, and then off middle central Oregon associated with an offshore bank, Hecata Bank. Conversely, if we look where there's high oxygen, there's an area right near the coast. You can see all along the coast, it's red. That's from the mixing, air-sea interactions, the crashing waves, the variable winds. That's a refugia. If there's low oxygen, that's a place organisms can go. And we see that. During these big events, we do get Dungeness crabs that run into the coast and into the estuaries. It's also south of Cape Blanco, that prominent point that sticks out around 43 North. The shelf gets quite narrow to the south of there, and that's high oxygen as well down there. And then again, way up north off the Strait of Juan de Fuca, where presumably there's a fair bit of tidal mixing and other effects. So let's talk a minute about why that might be happening. So here's some ideas behind that, and I'll show you some further evidence. That region off Grace Harbor on the Washington Shelf, that's a wide continental shelf, so a longer time to retain that water before it's flushed off. Around the Columbia River plume, remember I talked about hypoxia being associated with river plumes putting in excess nutrients. It's actually not excess nutrients, but I'll show you how the river plume facilitates bringing ocean nutrients up into the light zone. So that area is prone to hypoxia. And the last one is sort of what I've been working on for quite a while, is how do that strong along-shore coastal jet interact with the bottom and make these retentive areas that are super good incubators, and that they hold this water near the coast. Near the high dissolved oxygen, we've got mixing near the shore, potential tidal mixing, and then I mentioned the narrow shelf. All right, well, let's just test that hypothesis about the shelf width. So you just take the shelf width on the right diagram, you look at what the lowest oxygen, actually you average the oxygen across the shelf at that point and plot it up. And you can see there is an indication that the wider the shelf, the lower the dissolved oxygen. So that seems to hold up. What about this flow topography interaction? Well, as that upwelling jet comes screaming down the coast, it encounters this bank and does not want to go up and over, so it just simply goes around the outside. It creates a little extra upwelling through the centrifugal force, and then it isolates an area of low flushing inshore. And that's just shown by some data here where we mapped the temperature on the left, the surface currents in the middle, and then the chlorophyll on the right. And you can see the jet sweeping around the enhanced upwelling inshore and the enhanced chlorophyll bloom. And if you just plot on top of that the dissolved oxygen, this is now down near the bottom, you can see that that's quite a hypoxic area. All right, so we're just starting to put together some oceanographic processes behind this. Let's look at that river plume one. So on the right-hand image, that's a chlorophyll image where there's enhanced production associated with the Columbia River there, coming out just north of 46 North. And again, that's not high in nutrients. Instead, it's the mixing and the interaction at the base of the plume with the ocean water that pulls the nutrients up into the euphotic zone. So that's why that area seems to be more prone to hypoxia. All right, so let's take a little peek over time. I've replotted the 2021 over there on the right, and then we're going to go back and look at the groundfish data. So these are surveys that are carried out each year from 2009 to 2018. You can see all the data that's on there. And if you squint, you can see the same features. So that shouldn't be a surprise because the groundfish does go into the plot on the right as well. But it's showing those areas that I mentioned, both in the high oxygen and the low oxygen. You do notice, though, that the levels are changing. So we're seeing more deep blues in 2021. And there's been a fair number of papers that Amy Keller has led looking at the oxygen from the groundfish data, if you're interested. We went further back into the archives and pulled out all the data we could find prior to 1980. And again, those patterns are coming out with the bank and the Columbia River influence. But again, notice that the values are higher. So oxygens are decreasing over time over the shelf. All right, so what are we going to do with all this? And I'll just try to wrap it up here. On the right is a map of dissolved oxygen. In the middle is a map of Dungeness crab fishing intensity. And then the latest map is that our Bureau of Ocean Energy Management is starting to look towards areas to put in offshore wind farms. And so all of those things you really ought to use together to inform how we're going to sustainably use the ocean. So just to summarize, we had very robust at-sea sampling from ships, gliders, moorings. That near-bottom hypoxia was quite widespread throughout the upwelling season. The spatial patterns start to make some sense in terms of the oceanography. The near-bottom oxygens are decreasing with time, and we can use these maps to inform our management decisions. And then next up, of course, I mentioned the low pH waters. We also have things like marine heat waves and harmful algal blooms that we just were talking about. We can look at each of those and how it interacts in these areas. So thanks for your attention.
Thank you, Jack. We have time for a couple of questions. Manu?
I was curious if you find any significant relationship between these sort of larger scale Northeast Pacific events, these heat waves that happen at different phases of the seasonal cycle and have large meteorological changes. Do they actually relate to some of these more coastal scale hypoxic event like the strong 2021, or is it just sort of all over the map?
Yeah, I'll just take it one step back, Manu, is that of course, the marine heat wave is caused by changes in the atmosphere, and that changes the ridging patterns and the upwelling itself. So that supercharged upwelling, yes, due to changes in atmospheric circulation. But to your question, changes in stratification, where you're heating the upper layer and sort of putting a warm blanket over things such that you can't exchange as well. So yes, we do see effects like that. Yep.
Slava? Yes, thank you, Jack. But there may be two reasons why you have low oxygen water. First is more intensive upwelling in 2021, or the water which is going to be upwelled has low oxygen content. And one question. A second question, if you have the same signal in the wind pattern, I mean the like stronger upwelling winds in 2001.
Say that last one again, Slava.
I mean, it should be, if this effect of stronger upwelling, it should be correlated with wind.
Yeah. Yeah, so Slava is asking about the contributions of the wind-driven upwelling on the shelf versus changes in what we call the source water properties. And so what we're seeing is about, each of those adds about 50% of the variance. So yes, the source waters are modulating. It turns out in 21 they were not particularly low. That water is not hypoxic. It has to come up and be driven hypoxic by the shelf processes that are driven by the wind. Yeah.
Any other questions for Jack? Oh, yeah.
Thank you very much for a very interesting talk. Is your low oxygen water related to the undercurrent strength modulating this ENSO?
So the question is it's actually the California undercurrent down at about 200 meters that's bringing that water north. And the question is whether ENSO modulates that. At our latitude, there's much less effect than there is further to the south, say in the Cal-Coffee region, where Stephen Bograd and others have looked at oxygen. So as you go north, the ENSO signal is less impactful. So we don't have as big an impact.
Has there been a significant change in the proportion of the water column that is hypoxic? It looks like your mapping is showing some trends, but what about the vertical profile of the amount of hypoxia that you're seeing?
Yeah, and to be honest, when we first started looking at the glider data, I was stunned how much of the water column was hypoxic. It can, in some cases, it can be 2/3 of the water column. So during a strong wind-driven year like 2021 or 2006, yes, it goes well beyond the sort of 10-meter deep layer up to 2/3 of the water column, which, you know, of course, squeezes the habitat. This phenomenon was brought to our attention by the fishermen who noticed the octopuses climbing up the crab lines to get out of the low oxygen zone. Steve, do I get the last word? Okay, who knows when the Pisces swim is? Wednesday, 7 a.m. in front of the Paradise. Thank you.
Thank you, Jack. So our final presentation for S1 is by Dr. Misty Peacock, who's at the Northwest Indian College in Washington State in the US, and another very active member of the PICES community. She's on the MEQ committee and section on harmful algal blooms. Thank you, Misty.
Thank you. Hi, you guys. I promise to keep it to the allotted time so that you guys will be free to get ready for this, I guess, the reception afterwards. Thank you so much for the conveners of this session for having it, and also for Korea for hosting this meeting. I'm going to talk to you guys today about lifting the voices of Indigenous students to empower the next generation of ocean leaders. I'm Dr. Misty Peacock. I work at Northwest Indian College. It's in Washington in the United States of America. And if you're thinking about where this is, it's kind of the furthest northwest corner of the United States. It's just south of the Canadian border. So Indigenous peoples, this is the definition by the United Nations. Indigenous peoples are inheritors and practitioners of unique cultures and ways of relating to people and the environment. This is my lab manager. This is Rosa Hunter, and she is an Indigenous woman. She's an Indigenous scientist, and she practiced her culture and her science through an Indigenous lens. She's Jamestown Squalum, which is, if you, the previous talk that we just talked about, kind of next to Quinault Nation. It's actually just north of that. And she learned about red tide, harmful algae, and biotoxins in clams from her grandmother. So just to place a little bit where we are and the type of peoples that are working on ocean sciences here on your guys's, I'm not sure, the one that looks like the normal map that by Sylvie Arquez, that's the Salish Sea. And you can see that international border there between the United States and Canada. And the Salish Sea includes Puget Sound, the Straits of Juan de Fuca, and the Straits of Georgia. So down by Seattle is part of that, out into the Pacific Ocean on the Washington coast, and then up into British Columbia. That red outline is the freshwater drainage basin of the Salish Sea. And you can see that dot that says Bellingham, Washington. That's where I'm located. The other map, which some people may be familiar with, is actually a map of the Indigenous peoples of the Salish Sea. These are also the Laktamish people, or the people of the sea, the Coast Salish peoples. And they have been living here and practicing their culture and their science since time immemorial. This map is slightly out of date because it was made in 2014, but it kind of gives you an indication of the different groups of people that have been utilizing the resources in the Salish Sea for thousands and thousands of years. So we've talked about this a lot in this session, and I'm not going to repeat it too much, but the UN Decade for Ocean Science for Sustainable Development Goals really focuses on diversity and inclusion, international engagement, policy and management, diverse forms of knowledge, and outreach and communication. So this is a multi-stakeholder environment that involves generators of knowledge and users of knowledge. It integrates both natural and social sciences. It really includes Indigenous knowledge holders, and it also includes generational, gender, and geographic diversity. And so I think for quite a while in the sciences, this has been an important key point, and I really want to say thank you to the UN for kind of making this so front and center, because sometimes it can get drowned out with all the other things that people have to think about. I'm going to say something. I'm going to say that ocean sciences has failed at retaining Indigenous students. This is not a story of failure, so keep that in mind. This is not a negative story. I just want to say that and own that, because we really have. As ocean scientists, we have done a terrible job at including Indigenous students, supporting Indigenous students, and kind of mentoring them through the process to become ocean sciences themselves. So this is a paper from 2014. It says, where are the Indigenous scientific leaders examining the participation of Native American, Alaska Natives in weather and water academic programs in the federal workforce? In the federal workforce, less than 0.1% of federal workforces in the United States are Indigenous people. And I probably should have said this before for countries who are not familiar with North America. When I say Indigenous people, I mean the original inhabitants of North America. So these are the people who were here, living here before colonization. And this quote from William Wolfe, who was the president of the National Academy of Sciences, goes back all the way to 2002. He says, as a consequence of the lack of diversity, we pay an opportunity, a cost in designs not thought of, and solutions not produced. I think that there is a lot of recognition that when we don't have diverse people working in sciences, then we don't have diverse solutions. Some of the previous talks today have really focused on that, and I am appreciative of that. So this is a graph from the National Science Foundation. This shows the degrees that are granted in the United States to STEM fields. So the light blue is Bachelor in Sciences in STEM, the green is Master's, and the dark blue is doctorate degrees. And you can see from 2008 to 2018, there has been some marginal increase for people of color. So this is not Indigenous people specifically, this is minorities in the United States of America. But in 2014, only 0.4% of master's and PhD degrees were awarded to Indigenous scientists. By 2018, it doesn't even register. There was not a single Indigenous scientist who graduated with a PhD that was reported to the National Science Foundation. Thanks. In 2019, only 169 Bachelor of Science degrees were awarded in Earth Sciences to Indigenous students. And so if you think about how large the United States of America is and the fact that about 2% of the population identifies as Indigenous, this is really pretty terrible that only 169 Bachelor of Science degrees were deferred to Indigenous students. So one thing that America does have are tribal colleges. These are land-grant institutions that they have stakeholder engagement, and so they're chartered by a tribal nation. In Northwest Washington, we have Northwest Indian College. And so this actually started out as the Lummi Indian School of Aquaculture. It has a long history in marine sciences, and it has about 430 students who attend it. Of those students, 93% of them identify as Indigenous, and we serve more than 130 tribes, and this includes Native Americans, Alaska Natives, and Canadian First Nationers. And so we also are a 4-year degree granting university that has a Bachelor in Science and Native Environmental Science degree. And so we have about 60 students each year who are in that program earning their Bachelor of Science in Native Environmental Science. We are also the only tribal college that has a marine research center. So I'm the director of the Salish Sea Research Center. It's a 4,200 square foot research center. We focus on marine research. We prepare the next generation of Native environmental scientists and leaders. We foster respect for Indigenous knowledge. We are actually inclusive of that Indigenous knowledge within the science that we do. We provide the students with opportunities to gain solid backgrounds in scientific methods, critical thinking skills, and self-motivation. And we build tribal prosperity through place-based teaching, research, and extension. We also have the Tribal Colleges and Universities Enterprise Advancement Center for Community Marine Research, which is too much to say, so we just call it the T Center. And so what this does is an NSF-funded program that identifies community research projects. It supports tribal nations in food and data sovereignty and engages the community in knowledge exchanges. And I'm going to tell you why this is so important when we're working with our Indigenous students. We really focus on engaging our Indigenous scholars. And so before we have our students work with us at the Salish Sea Research Center or through the T Center, is that we invite them to partner before the internship program begins. This is some pictures of our students who are actually working on the sciences. And what we do each year before we have our students do this internship program is we do a couple different surveys. This one was done in 2014, 2018, and 2021. We actually went out into the communities, the tribal communities that we serve, and we asked them as stakeholders, what are the research projects you would like our Indigenous students to work on. And these community stakeholders said the biggest concern for them was emergent harmful algae and biotoxins in the Salish Sea, decreasing forage fish stocks, and monitoring for climate change, which I think is kind of a theme here at PICES, are some of the concerns that we see in our shared waters. They also wanted to focus on management and policy decisions so that there's safe seafood for the community and they could prepare for the future in case there needed to be that preparation. Lastly, they wanted to support their cultural identity and their ability to practice sovereignty and make policy decisions. And what that means is that they didn't want scientists from outside the community coming in and telling them how to manage their fisheries, how to manage their stock, and how to do what they need to do for their people. What they want is an appropriate channel where the data is completed and then provided to the tribe for them to make their own management and policy decisions. We also surveyed the students here, and we did it as a word cloud. And you can see the larger the word is, that means the more times the students actually said this. And you can see kind of focus here is sovereignty, place-based research, graduate school ways of knowing, self-determination, celebration, voice, communication. And so we really wanted to build our internship program that would support our students in that while they studied their marine science. So we designed an 8-week paid internship program. I put paid in there because I think it's really important. A lot of our students are underpaid. A lot of our students are considered non-traditional students in the sense that they are coming back. They're older than a lot of the 18 through 22-year-olds that you see at undergraduate colleges in the United States. A lot of them have families already. A lot of them are single parents as well. And so it was really important that we supported them during this program. Each year we have between 10 to 15 Indigenous undergraduate students. And so if you think about it, we have 60 students in our program each year. And so about 10% of them, a little bit more, about 20% of them are actually participating in our program. This is a competitive program, so they do have to apply to get in and be committed to that 8-week internship. We have curated research projects, so we do that survey and we ask them what they want to work on. And once we have that information, then we actually partner them with research mentors who can help them. These research mentors are taken from within the community. We work with natural resources departments or their faculty or researchers at Northwest Indian College. We also work with federal and state researchers. We've had mentors from NOAA, from University of Washington, some of the larger Research One universities in the area. And our students are required to give presentations of their work. We also provide for them support to go to one conference a year. So if they complete the internship program, then they have that opportunity to go. If you've ever had a graduate student, you know how important this is and how competitive it is for getting into graduate school to show that you have been able to complete a research project and then present it at a conference. So I'm going to talk to you about just the last 2 years, the kind of projects that we've been doing. I said 2 years, it's actually been the last 5 years. We did have a small break for, I think there was a virus that was going around, but we actually continued. We had online classes, and that was a whole lot of fun. It was not fun. But we did continue our internship program. We're so happy. We had our students back in the lab this summer, which was really nice. But we listened to the community and we started working on projects that included harmful algae and biotoxins. In the Salish Sea, our kind of biggest harmful algae of concern is paralytic shellfish toxins and paralytic shellfish poisoning. And so we do have the capacity at the Marine Research Center to run these toxins. We do have a liquid chromatography mass spectrometer. And so our students learn everything from collecting samples to preparing them in the lab to running them to getting the data and then deciding what to do with that data. We also belong to parts of various federal and state groups that monitor for harmful algae, and so we also work with the students on how to provide that information to the public. We talk a lot about management and policy decisions. because the tribe that we work with, Lummi Nation, actually manages 13,000 acres of tidelands. And so they determine when their shell fisheries are open and when their shell fisheries are closed. And so one of the things that they do is they work with us and we provide the data to them so that they can make those management and policy decisions. These signs are seen everywhere in Washington State. We see them all summer long, and into the fall, they say, don't eat the shellfish because they're toxic, they have biotoxins. When we see these signs, we actually do the opposite, and we go out and start digging clamps because we want to see what toxin is there. And so that's my student and then my lab manager again. A second project that we work on are forage fish, the tiokwe, as they say in Laktamish. And so this is a small fish. It's about 3 to 4 inches long. It's also known as the hooligan, not to be confused with its neighbor to the north, which is the eulogin, and slightly larger. It's a completely different species. This is a longfin smelt. Its closest cousin is down in San Francisco Bay. But this particular fish is also known as the Thanksgiving fish. And Thanksgiving in America is in late November. This fish comes from Bellingham Bay, from the Salish Sea, and comes up the river. It usually starts around November 10th and ends by December 1st. And the tribal people, since time immemorial, have been out there collecting this fish, and they collect it in such large quantities that they can smoke it and they can eat it all year round. And it also supplements their subsistence harvesting when it is wintertime and they may have less access to food. You can see that net, you can see the student holding this net. This net is maybe this big around. It's huge. But luckily, the pole is actually aluminum. It's hollow. And the reason for that is because you actually put this net into the water, and the reason it's so long and so large is because of the flooding of the river. So the river, you have to stand very far back on the bank, and you hold this pole to your ear, as you can see in that top picture, and you can hear the fish go ping, 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 so you know when to pull it up and put it in. And when I say that the tribal members collect a lot of these fish, they collect them in the size of pickup truck beds. Right? They fill up their pickup truck bed with these fish, with buckets of these fish. This is an unmanaged fishery in the state of Washington. So we are working with Lummi Natural Resources and the state of Washington to kind of monitor for these fish to determine if it needs to be a co-managed fishery. I say co-managed because in the United States, these tribal people have access and permission to fish here. And so it would be any sort of fishery would be managed with the state of Washington as well. We have also moved on from just collecting the fish. We're actually doing most of our monitoring with eDNA. As you can see, that kind of pull into the water. And we're also trying to determine where they might be laying their eggs and see if we can capture that, the spawning event. There's going to be another talk specifically about this fish on Friday, September 30th in the fish paper session. Called Wanted, Searching for Longfin Smelt in the Nooksack River in Bellingham Bay by Rachel Mallon. Our third project is our newest project. This is the invasive European green crab. If you are in the west coast of North America, you have probably heard about this. The state of Washington declared it as an emergency last year, and agencies are working with tribes to stop the growth of this invasive crab. It was probably brought to the north coast of America through bilge water, but it is definitely there now. A particular concern to the tribal nations is the fact that when this crab is an adult, is when you have the Dungeness crab juvenile hatcheries, as well as juvenile salmon hatcheries. And so there's a lot of worry that this adult crab will be eating those juveniles before they can get out into the ocean and grow. And Dungeness and salmon are the most commercial and subsistence lucrative fisheries in Washington state and to our tribal nations in the Salish Sea. So we actually have a student here, and she's working on an eDNA project with this crab. She's measuring the crab right there. And this student is actually, she finished her internship this summer and has been hired by Lummi Natural Resources to continue on with this crab project. The last part of our internships is community engagement, and I cannot stress how incredibly important this is. In a lot of the sciences in North America, the people who are scientists often are Caucasian white males. Some of my favorite scientists are Caucasian white males, but it can be really hard for people of color, women, indigenous peoples who don't see a scientist that looks like them. And when we talk about the early career program, especially here at PICES, one thing I think we need to think about is maybe also starting even earlier than when they are getting their science master's and PhD degrees, right? And so how do we bring these students into science to begin with? How do we give them the tools and the confidence to grow into ocean scientists? And so one thing that we require our interns to do is to go out into the community and show what an indigenous scientist looks like. And so we actually work with the preschool program, and we bring fish and we bring invertebrates and we let them touch and feel and grab and learn about them. We also work with Quileute Nation, which is just north of what Jack was talking about at Quinault there on the ocean coast. We do a 3-day summer science program with the students. And we also bring all of the tools and supplies that these students need so that we can show them. But the researchers aren't showing these students what they're doing. The interns are showing the students what a indigenous scientist looks like. We also do something called a nested mentor model. This is something that's been around for a long time, but essentially we have lots of layers for our mentorship. And so we don't just have our undergraduates working with full-time faculty or researchers, we actually have a middle layer, and that's graduate students. And so every summer we hire at least 2, sometimes more graduate students. These graduate students are either indigenous graduate students or people of color. From the community to work with our students so that they can guide them. When our students have questions about graduate school, it's a lot easier to ask somebody who's doing their master's or PhD rather than somebody who's already done it before. And so you can see here we have Jacqueline Garcia, who's at nearby Western Washington University, and she worked with us for the summer and our students, and she was doing her own project on biotoxins in butter clams in the Pacific Northwest. Our students are doing great. So since 2016, we've had 62 students go through our internship program. And so those 62 students, about 40% of them are repeats. So these are students who have done it 1 year and then go on to do it the next year, et cetera, until they graduate. And our students do really good work. One of the coveted things is our student Shelby Madeira actually published this article. We were looking for yesotoxins in oysters in Puget Sound. Our students are producing technical reports, and so this is a look at the freshwater at Nez Perce Nation. And so she learned GIS and ArcGIS and how to produce these maps for her people. And our students are also delivering podcasts. And so Human Elements using indigenous knowledge to identify toxic shellfish. And so this is an NPR series of Human Elements that looks at women and people of color in sciences. Our students, like I said, are required to give presentations. They go on to international conferences like PICES. That bottom corner is our students in Canada. When PICES was in Victoria, they present at AGU, they present at SACNIS, which is a conference for I'm not going to remember the acronym, for Hispanics and Native Americans, and in sciences. And I just want to highlight some of the success that our students have done. We have 9 students who are currently in graduate school. So 9 of those 62 students went on to graduate school. 6 of them are getting their masters, 3 of them are getting their PhDs. We have 2 students who have completed their masters. In the center there is Danae Jed, who just completed her master's in Native Environmental Science at SUNY, so the State of New York school system. We have 11 students who have gone on and are working in natural resources positions. And we have 2 students who have continued on and are interns at NASA Ames Research Center currently right now. So our students are not failures in ocean sciences. Our students are going through the program and being mentored in a way that helps them succeed to get into ocean sciences. And I just wanted to say Haishka, which in Lami means thank you. And you guys might recognize that this was the sporting event at Victoria, which is the last time we were in person. And Mikhail right there scored a bullseye. So, thank you.
Thank you, Misty. Any questions? Comments?
Thank you, Misty. What are the most meaningful ways that PICES can include Indigenous voices in next year's meeting?
So I think one of the ways that PICES could really include it is to start now. PICES needs to reach out to the community, and they need to ask how they would want to be included. Seattle is a great place for this. There is a strong history of Indigenous tribes there, but rather than calling and inviting and saying, hey, can you do X, Y, and Z, maybe reach out to the community and ask them how they would like to participate. And also the strong support for our young students, right? The ECOP program for PICES is amazing, and I think that our students would really, Indigenous students would really want to participate in that.
I have a question for which I don't know the answer, and I'm not expecting you to answer, but there was some chats, for example, within the GEOS program of developing an online master in ocean solutions to train sort of the, a generation of leaders that can navigate this complex spheres that is evolving. And of course, just having an online master wouldn't make sense, so maybe it would be good to have campuses where students can meet and stuff. But if you were to think about designing something like that, do you think it's sort of a viable thing to do, or maybe it's just too ambitious, because we have so much diversity around the world, but the idea was an inclusive master too.
I think it's an excellent idea. I think one of the largest issues that our students have is their ability to pick up and move. It's really asking a lot to ask them to move from their home, to move from their people, to move from their culture and their community, especially if they have a family, especially if they don't have the funds to support it. And so one of the greatest barriers to getting our students into graduate school is that they physically cannot leave the place that they're at. You think about Indigenous students, a lot of times are in multi-generational families. They're caring for grandparents, they're caring for aunts, for uncles, and stuff like that. So having access to an online program might be really beneficial in getting some of those voices into ocean sciences. Except you'd have to support it with technology, because a lot of, in America, a lot of Indigenous communities don't have access to basic internet.
Any other questions for Misty?
Thank you. Hey, Misty, that was a great talk. So I'm in the Pacific Islands, and so I caught your statement of the slide where you spoke about those of the scientists of different color and the reluctance of some of the tribes, the communities to embrace them. But it's been my experience at times where even when their own young ones or their own people go out to get educated, they bring back Western science. And that flies in the face of many of the elders who embrace traditional ecological knowledge. And while in many cases the Western science is saying the same thing, although in different words, they're often met with skepticism, and sometimes, often, I don't want to say ostracized, but they have a very negative welcome back, if you will, when they come back into the communities. Have you encountered some of that in the tribes that you engage with?
Yeah, so you've touched on something that's really complicated. There are definitely people who frown on their younger students going out into the world and bringing back what they call Western knowledge, right? And so they're using Western knowledge as a dichotomy from traditional ecological knowledge. There's another group of people who see it as a tool to help engage traditional ecological knowledge, right? To use both that and the other one. We definitely see both sides of that. One thing that some of our students do, and there's a movement in the United States, is to be really inclusive of traditional ecological knowledge. And sometimes this is a difficult concept to understand from a Western perspective, in terms that they say, okay, we have this Western science. We go out, we take temperatures, we take our AUVs, we take our genetics, and we get this data. We also want to include traditional ecological knowledge, but we don't really have a framework for putting it in there. And I think that what the movement more now is to say, start from a place where traditional ecological knowledge is considered a different way of knowing and not something to be included in Western techniques, but something that's outside of it, but as equally as important. And I find that our students who kind of look at it that way and can interact with our community in that way, kind of maybe sometimes do the best out in the Western world. But there definitely is some people within the community who frown on that.
Okay, well, thank you very much, Misty. That was a great presentation.
Thank you.
And thank you to everyone for participating in the session today and our speakers. And please come back for the opening reception at 6:30 in this room. Right. Thank you, everybody.